Good morning, everyone. We will wait for a few more participants to join. So we will start the FDP at 10:05 sharp. We will wait for few more participants to join because we have over 100 participants with us. So we will have to wait for 5 minutes. So kindly be patient. We will start exactly at 10:05.
Okay, ma'am.
A very good morning to one and all. I, Divya Gupta, extend a very warm welcome to all the honored guests and my colleagues on behalf of Department of Management Studies, Jagannath International Management School, Vasant Kunj, to the day 2 of the 1 week FTP program on Advanced Time Series and Panel Data Analysis. So this pre-break session, for the first part of the session, we have Dr. Himani Gupta with us. So I request Dr. Himani Gupta to take over. She is going to share with us today her knowledge on the topics such as deterministic trends, stochastic trends, structural breaks, ARIMA, etc. Ma'am, I request you to grace the occasion.
Good morning, all. So how was our learning in the previous day, that means first day of our session?
Good morning, ma'am.
Good morning.
Morning, ma'am.
Good morning. So let's start our session.
Okay, ma'am.
So yesterday we were somewhere about here. Okay. So yesterday we started with this and we learned how to make the graphs. Now, any doubt in graphs?
Excuse ma'am.
Yes.
Ma'am, I have one doubt to the last class.
Yes.
Actually, ma'am, when I'm installing this Read Excel package
Yes.
in our studio, then it is showing one error. It is coming that this package may be available somewhere else.
No, sir, it's available in
I
R
don't know.
only. You just have to install it. It will be there. It will automatically be installed. Even you don't have to put it in the library.
Madam, but it is showing error.
I'll just show, when I'll come to R, I'll just show it again.
Okay.
Just a minute. So we have done the time series plot. Now we are going to learn about parallelogram and descriptive statistics in R Studio. So first of all, we are going to learn parallelogram.
I just have one doubt. Can I ask it now?
Yeah.
Or shall I?
Yeah, you can ask.
In the theoretical portion, you said that there are in the features of time series. You showed us there can be random walk and non-stationary. Under non-stationary, there can be random walk and random without walk without drift. And also stochastic and deterministic.
That we are going to do it.
Ma'am, I just want to ask one thing. It's a basic question actually. That if it is a non-stationary, first we classify to random walk and
no. Random walk will always be non-stationary.
And random walk without drift will always be stochastic.
Yeah, it will always be stochastic, and we have to convert it into the stationary one.
Okay, ma'am.
That is a stochastic trend. That will be a stochastic trend. It can be with drift. It can be without drift. So if it is with drift or without it, that means it has a unit root, and we have to convert it in the stationary part.
Ma'am, just one random walk with drift will always be
it will always be non-stationary.
And deterministic.
Deterministic trend will also be non-stationary. But the data that I have given you, because it's you can say it's an hypothetical data, it's not a real data for the deterministic trend on the file that we are working. Because in the real world, you will not find the deterministic trend. So just for the learning purposes, maybe we can have it in the real world also, but it's hardly to find. That means we can say that 1% chances there you will find the deterministic trend in the real world. So, but you should be aware that if you are getting the deterministic trend, how to make it a non-deterministic trend. That means how to detrend it. So that's why we are going to learn it. So the deterministic file that I've shared it with you, that is an hypothetical figure. That is not a real figure. The share price file that I have shared, that is a real. I have extracted from the stock market only.
Okay, ma'am. Okay, thank you, ma'am.
Okay. Okay, now let's start with parallelogram. Now, parallelogram also shows us about the diagram, and we can also study from this. Now, if I'm going to show you the parallelogram from the R Studio only. Now, yes. Now, everyone has the R Studio now. Now, everyone knows how to download the files and how to import the files. So let's start.
Yes, ma'am.
Import the file. Let's import the file sales detrending. So let's start with detrending part only. Now everyone is getting this two figures, sales and turnover. Now everyone has got this. Now let's attach the file.
Hey,
Now
ma'am,
done.
there is one doubt. One participant is saying, please repeat this process.
Okay. So what you have to do, whenever we have to attach the file, you have to import the data set first. That means whatever files we have to import, we can import even the Excel file, we can import SPSS file, SAS file. So any file we can import it in R. So first of all, go to import data set. From Excel, you will find this window. From there, you have to browse it. So in my system, I have put the file on the desktop. So I'll go to the desktop, then my data files. In data files, the file is sales detrending. Just open it. So on the screen, you will see the two files, sales and turnover. So I'm going to import it. And once I import it, you can even click over here. It's a view sign. You will see one hand. You can just click it, view. So on the first window, you can see the two files, sales and sales turnover. After that, what you have to do, you have to attach that file. Attach sales. Now I have attached this file. So that means file is ready so that we can work on this file now. Now everyone has reached at this stage. Can we start?
Yes, ma'am.
Yes,
Now.
ma'am.
Excuse ma'am.
Yes.
Ma'am, I could not import these files because, you know, the problem which I have already told you that
Okay,
I
sir.
could not.
For that, yeah. Okay. You can go to tools, install package.
Yes.
Once
Yes.
you go to install package, you just write read Excel. Read X. If you just write read X, you will see on the drop down there will be read Excel file. Click on this and
Madam,
then
I'm doing
install.
the same thing. I'm doing the same thing, ma'am, but it is showing error. You know, if you give me share right, then I can show you the message which is coming
Sir,
up.
but it won't be possible because we have to cover so many part in today's session.
Okay.
So
Don't
you
know
just
what is the
try.
problem.
You just try. It will be there.
Ma'am, I have a very small query. Actually, before the class started, I opened my R. It was showing on my screen, but unfortunately, my laptop closed and it went off. Now I'm not able to locate where I saved yesterday's work. So when I'm going to my saved R Studio, which file am I supposed to open?
Ma'am, don't worry about that. You just open your R Studio.
So R Studio, there are a lot of files actually there.
No. You go to Windows and just type R Studio.
Oh, okay. All right, I'll do that.
And can you just repeat how you have attached?
You have this imported
Yes,
the file. Now you
ma'am.
just write
Everything done.
attach. Just write attach. If you
Okay,
will
ma'am.
write attach, you will find on the drop down menu word attach. After that, you
Okay.
have to write the file name. File name is sales_detrending. So it will automatically come and you will see the file name. In the front of the file name, you will see the small Excel is given. So
Okay.
when the small Excel is given, that means it's a file name. And when you will find this pink bar, so that means this is a variable name.
Okay.
Ma'am, I just went to that import data sheet.
Yes.
And then Excel, selected Excel, and then went to browse and I selected sales_detrending file.
Yes.
Now, once I have done that, unlike what is your screen is showing, the earlier share price, the file is actually not visible anymore. Now it is showing sales detrending. It appears
Yes,
to
it hardly matters. It hardly matters. I can remove this file. If I want to remove this file, I'll just write RM.
It is automatically have happened in my case, and should I go for the third shell? That is the third
No,
part.
no. It hardly matters, sir. I don't need share price file right now. Now
Oh.
I've removed the file. See, the file is not there.
So now I'll go for the attachment.
Yes, you just go to the attach sales detrending.
Right, thank you.
Ma'am, in my case, in this sheet, sales detrending file is not showing, but it is showing some values.
No, sir, it will be showing. It will be there. You will see sales underscore detrending file will be there, which will be having two variables.
No, this file is attached, but some values is showing, ma'am, in the environment. Some values are showing. Axis dot data, axis dot like this. So many values is showing.
Leave it, sir. Leave it. It hardly matters.
Mm-hmm.
Now the file is attached. Now let's see how we are going to make ACF. That means now we are learning how we are going to make parallelogram. We have two types of parallelogram. One will be ACF, that is your autocorrelation, and one will be PACF, that means partial autocorrelation. So you can say first thing we are going to learn is ACF, and second part that we are going to learn is PACF, partial autocorrelation. So let's start with the file. So first of all, write ACF. You will find ACF over here and just write the variable name. Either you can make it for sales or you can make it for turnover. So let's make it for sales. So once you write first three letters, automatically the sales word will come and you have to click it. Now you can see the parallelograms are there.
Excuse me, ma'am.
Yes.
If I'm not disturbing you, after importing sales detrending that I have done, in left first corner, I can see all the values like your screen.
Okay.
But after that, what is to be done? I missed out.
Attach, ma'am, attach the file. Just write attach and the file name. It will be attached.
Ma'am, sorry. This file name says sales underscore detrending. So have we detrended some file before doing?
On this file, because I'll save this name because this is the file on which we are going to learn how to detrend it.
Okay, ma'am. Okay.
Ma'am, apologies, but I'm not able to locate my RStudio. So do I need to install it again?
No, it will be there. Ma'am, you just go to window and okay, you will see the search window over there on your system. Just type RStudio.
Ma'am, can I ask a question?
Yes, ma'am.
Ma'am, this auto correlation is basically what we are doing is that the sales the sales figures of current year is being correlated with the previous year. That's what we are doing. And ma'am, this is a parallelogram that you have generated.
This is a parallelogram that we have generated.
Can I make a request? The participants can ask questions a little later, otherwise we will not be able to.
Yeah, I know. Okay, now ACF is clear. So how we are going to make the ACF? Now
Sorry to disturb. After ACF, only sales we need to write, not detrending.
No. You just have to write the variable name. See, sales detrending is a file name.
Okay, and it will be drop down, no?
Yeah, it will be drop down. Everything will be drop down.
Sales also drop down?
Yes, if I want to make the ACF of turnover, let's say I write ACF and on the bracket I will write turnover.
Thank you, madam. I got it. Sorry to disturb.
It will be your turnover graph. Now, what is ACF? What is autocorrelation function? So ACF is autocorrelation, which shows you that how the values are related to the previous year values or previous time period values. So it's showing that, see, over here, the first year value or first day value is correlated to the previous year or previous day. Second is correlated with the third day. Third is correlated with the fourth day. Fourth is correlated with the fifth day. Now, how I came to know that these are correlated, you are seeing these two lines, upper limit and lower limit line. Whenever your parallelogram is going to cross these lines, upper limit and lower limit, it means there is a correlation between the previous term. That means previous lap. or you can say previous time period, there is a correlation between them. So that means if I am going to find any future value, it will be related to its past. So your autocorrelation is showing you how many lakhs we have to take. But now in this figure, you will see that all the figures are autocorrelated. And this figure is also showing me that my data is not stationary. My data is non-stationary. That means if you are getting all the figures like this, all the bars are crossing this line, upper limit line. So it's a non-stationary data. We cannot work on this data.
Ma'am, can you repeat this one more time?
Yeah.
Ma'am, especially the lag part, ma'am, I did not understand. How did you that lag thing come up in the
autocorrelation means that your data is correlated between the previous lag. So that means if my data is year wise, so that means first year information is hidden in the second year, in the previous year information. So previous year is hidden in the previous to previous year, preceding previous year, and last 3 years information is hidden in the last 4th year. So that means all the information are hidden in their previous lags. So all they are correlated. Year 1 is correlated by year 1, t minus 1, t minus 1 is correlated with t minus 2, t minus 2 is correlated with t minus 3, t minus 3 is correlated with t minus 4.
Excuse me, ma'am. You said what shows this autocorrelation?
That they are correlated with each other.
No. You said something about the graph that
yes,
one line
graph, yes. So you are seeing these two lines, upper limit and lower limit. See, all the graphs, all these parallelogram are crossing these graphs, these lines.
Okay.
So that means they all are correlated. And since they are all are correlated, that means our memory is not finite. My memory is infinite. These all are dependent.
They are related to previous
yes, they are related to previous year values.
Okay.
So they all are related to their previous year values. So it shows us that my data is non-stationary. Non-stationary. So now we can't work on this data. So first of all, we have to convert our data into stationary one. So now ACF is clear. Now let's move to second part, PACF. Now just write PACF.
Excuse me.
Yes, sir.
Can we say that in this case there is a positive autocorrelation because no bar is towards the
yes, it will be a positive, sir, because no bar is going to the negative part. So it's a positive correlation.
Okay.
Now just learn PACF. It's partial autocorrelation.
Excuse me, ma'am.
Yes.
Ma'am, what will be the effect if we take this non-stationary data series?
So, ma'am, you will get the results to be furious. It won't be, you can't believe on that results. Plus, we cannot forecast on that.
Okay, so it means we cannot develop a model based on
this.
Yeah,
we cannot develop a model. Our model will not be a correct one.
Okay, thank you.
Now, see, this is partial autocorrelation. Now, what does partial autocorrelation means? Partial autocorrelation means we are going to find the relationship between two previous terms, but not immediately preceding. If I have to find the relationship between t minus 1 and t minus 3. So what they are doing, they are taking care of t minus 2. That means relationship of t minus 1 and t minus 2 is adjusted. They are not considering the relation. What is the relationship between t minus 1 and t minus 2? They are just considering the relationship between t minus 1 and t minus 3. So it's being taken care of. So that's why you will see in this graph, many lags or many parallelograms are within these two lines. They are not crossing these two lines. So when we will be exactly working on the stationary data, you will also see that these lines will show us the lag, that on which lag our dependency is there. So how we are going to create the model? Whether
so
I'll
first, sorry, ma'am.
Yes, yes.
Ma'am, the first line will be T0, the next line will be T minus 1, the third will be T
minus
minus 2,
2.
like that it will be
Yes,
continuously
yes,
decreased.
It will be, yes, it will be continuously decreased. Now over here you will see that these are coming in the negative part. So they are negatively affecting, but still they are not crossing this line. So they are not dependent. Now if I see this PACF, so there will be lag 1, lag 2, lag 3, because it's also touching. And then it will be somewhere around lag 17 or 18. Now got it? Any doubt till here? How we are going to see ACF and how we are going to plot PACF?
Ma'am, I have understood the concept, but I just want to ask, like अगर हम लोग अपनी किसी भी कंपनी का प्रॉफिट्स देख रहे हैं, ठीक है, और उसको हमने ऐसे ही प्लॉट कर दिया, तो यू सेइंग कि इट्स बेटर कि हम लोग PSCF यूज करें?
No, we have to use both. Auto correlation also, PACF also, but we have to use on the stationary data. If you are going to use it on non-stationary data, your result will not be fruitful.
Okay.
Ma'am, I just want to know about these two horizontal lines, dotted lines. You said these are the limits.
Yes, yes.
So these limits will be calculated by the software itself?
It will be calculated by the software, because we are not going into the statistical parts. We can also make it, but we are not going into the statistical part.
These are the limits of correlation?
Yes, these are the limits of correlation. So if your correlogram is within this limits, so no problem. If it crosses this limit, that means they are correlated to each other.
Okay, ma'am. Thank you.
Now let's plot this graph. Now, are you getting this graph?
Yes, ma'am.
Now,
it is a
yes,
deterministic trend.
Yeah, it is a deterministic trend. Now, what do you mean by deterministic trend? What is deterministic trend? Yes,
ma'am, it means that the ups, peaks and downs comes very close to each other. I mean, it is they come very fast and they go away also. The peaks and the high points and the low points, ups and the downs. Does it mean something of that sort?
Deterministic trend can be upward, it can be downward, but
Yes,
the deterministic trend means that the change is constant. For example, if I'm taking like year 1, let's say in year 1 my data is 10, in year 2 my data is 20, in year 3 my data is 30. Now you will see that the data is increasing by constant number. There is a difference of 10 only, or I can say, let's say year 4 my data is 39, so it's also near about constant, so it's increasing by 10 every time, 10, 9, 11, or you can say 12, so it's near about the change is constant. So whenever the change is constant, you will name it as a deterministic trend, and when the change is not constant, it will be named as a stochastic trend. That means irregular trend. We cannot determine it. Deterministic trend means you can determine what will be the next sales. So once we are able to know what will be my next year sales, I can determine it, I can name it as deterministic trend. For example, I say that for every year, my sale is going to increase by 10%. So that means I can determine that in the next year, if it is not 10%, it can be 9%, it can be 11%. So that will be considered as a deterministic trend. And if I am unaware, for example, COVID is there, I'm unaware whether my sale will increase by 10% or it will decrease by 10%, or it will be 0% or it will shoot up by 100%. For example, if you will see in the retail, shops are locked down. There is a lockdown, so shops are closed. So that means the sale of the shop owner is 0. But if you have an online portal, you can see the sale of the Amazon, it's shooting up. So when you are not able to determine it, what will be your next step? That will be an irregular. So that will be named as a stochastic trend. And if I can determine it, the change is constant, I can name it as a deterministic trend. Now, if this is my data, then it is a deterministic trend. If let's say I take it is at 10, it will be, let's say, instead of 10, it is 25. Now, instead of 30, it is 40. Now again after 40, it's coming to be 12, and then year 5, it's coming to be, let's say, 48, 46. So that means it's an irregular variation. I cannot determine what will be my future sales. So if this is a data, irregular trend is there, so I'll name it as stochastic trend. But the main thing is that neither I can work with the deterministic trend, neither I can work with the stochastic trend. We cannot work on a non-stationary data. So first of all, what we have to do, we have to detrend it. I have to remove this trend that the trend is moving upwards. I have to remove this trend. And similarly, in the stochastic also, we have to remove the stochastic trend. So first of all, let's learn how to detrend it. If I have to work on this data, so how I am going to detrend it, because now I have learned that this data, that data I have given it to you, that is detrend, that is a deterministic trend. So let's learn how to detrend it.
Ma'am, I get very confused wherever this deterministic trend is about change in
Yes.
the data. And
Yes.
when we were doing the random walk with drift and without it, there was no change. There was nothing change. It was just a data directly that was plotted.
That was also a change, but change is unknown.
I mean, I get confused. I mean, there are 4 types of trends, 4 types of series that we can identify. That means that one is
no, one is don't confuse with drift. Drift is just a constant thing. So whenever you write the equation, intercept is there, intercept is known as drift. So don't get confused with drift. Just keep drift aside. We have 2 kinds of trend. One will be deterministic trend and one will be stochastic trend. Stochastic trend means the change is unknown, and deterministic trend is change is constant and we can determine it.
Okay, ma'am. Thank you, ma'am.
So now we are going to, first of all, we are going to see how we are going to detrend it. So I'm writing the command to detrend it, but before writing the command, we have to install one package. So go to tools, install package LM test.
Ma'am, yesterday when I installed RStudio, it by default asked me to install certain packages. I just clicked yes, and I don't know which packages it has installed.
It hardly matters, ma'am. Just do it again.
So I mean to say we need to again reinstall whatever you are suggesting.
Yes, you have to reinstall it. Or if you want to test whether it's already there or not, you just type library over here.
Okay.
And if on that library, just write the test. For example, I am writing LM test. I have already installed it, so it will be in the drop-down menu. If you are not seeing,
there is one question in the chat box. One participant is asking, if the real observation showed deterministic or stochastic trend, why do we need to detrend it?
Because we cannot forecast it. If we are going to forecast, the result won't be accurate one, because future is uncertain.
Ma'am, in this graph,
yes, but there are certain parts that we are not going to learn in this session. Suppose we are using ARDL model, and ARDL model says that we have to work on the original data. They don't want that the data should be converted to the stationary. So if you are working on the ARDL model, you can directly do on your direct data. That means in that case, you don't have to convert it. Your software will take care of, and then the software will give you the result. But yes, if we are going to work forecasting, in case of forecasting, we have to convert it into the stationary part.
Ma'am, you said this is deterministic trend. How did you get this? I mean, I could not understand. By showing this upward trend only?
No, upward trend plus there will be the constant. You will see that the graph, it's coming down, coming up, and same part it's going up, down, up, down, up, down. You will see this a deterministic trend.
Same pattern is following.
Same pattern is there. Yes.
And the figures which you take were arbitrary.
Yes, yes. Because in the real world, you will not get this type of data.
And this is additive model.
Yes. Now, if you are getting LM test, that means the software is already installed. If you are not getting in the drop-down menu, so that means software is not installed.
I am getting an error when I am installing.
Where?
When I put install.packages LM test, it says LM test not found.
No,
but if I do it through tool,
ma'am, you have not used the drop down.
Participants are asking you to install When participants are asking you to please tell them how to install the
Okay.
LM test.
Now you have to just go to tools, install packages, and just write LM test.
Ma'am, through this I have installed, but if I'm just writing the command, I'm not able to. I don't know why that is.
Okay, ma'am, I'm just coming. Just install it. If everyone has, once you have installed, what you have to do, you have to attach it. You have to open a library. Now in library, just write LM test. You will get in the drop down menu, click on that and just enter.
Because if it's installing through tools, it should install otherwise also.
Yes, it can be, but tools
library is okay. I have done that library. Okay, ma'am. Thank you.
Now done. Everyone has done it.
Yes, ma'am.
Now can we move further?
Ma'am, just a second. Library I have done, but into bracket that in test doesn't come in drop down.
No. It's not in test. It's L. It's written L. LM test.
LM test, but that doesn't come in drop down, no?
Have you installed it? LM
yes,
test.
Madam. Yes, madam.
So just write library. Just write LMTE. It will come in the drop down.
No, it shows something. Berry package help POS is equal to 2 false, something like that.
That means when your test LM test is not installed properly.
Okay, I'll do it once again.
Yeah. Now,
Excuse me, ma'am.
Yes, sir.
Ma'am, if we are installing the package, if the message is coming like warning, unable to access index per repository, what does it mean?
Sir, that means maybe you have to upgrade it. You have to upgrade the package.
Okay, how we can do it, ma'am?
Sir, go to tools, again install packages and add, or you can directly do it by upgrade over here. Packages, and you will see update part in the fourth window.
Yes, ma'am.
So you can search the test over here, click over here and then update it.
Okay, we have to click it and then click on update.
Yes.
Now there's one thing. So whenever we are installing anything, we use library, and whenever we are importing some data, we use attach.
Yes. Whenever you are importing any Excel file or any SPSS file, that means on the file that you have to work, you have to attach it. And library means we are just opening a book that we are going to work on this book now.
Imani ma'am, I have a question.
It's not
please.
available for this version.
Ma'am, you have to update it then.
So Himani ma'am, I'm sorry, but finally I was able to open my window. I just wanted to ask that I have already installed LM test. Now, can I run ACF and PACF since I was not...
ACF and PCF does not require any package. That is inbuilt, so you don't require any package for ACF and PCF.
But now when after installing LM test, I'm writing ACF command, it's showing me sales detrending in bracket.
Yeah, so it will be shown, it hardly matters.
Okay, so it doesn't matter.
No, it doesn't matter. You just have to select whether sales or your turnover.
Okay, all right, sure.
Okay, now we are learning how I am going to detrend it. Now you can write any variable name. For example, I am naming the file as trend. You can name it X, Y, Z, whatever you name. So if you want to name it trend, you can name it trend. If you want to name it X, you can name it X. If you want to name it Y, you can name it Y. So just write detrend, then LM. Now LM stands for linear model. Bracket, done. And now you have to write the variable name which you want to detrend it. So let's say I want to detrend sales. So I'll select sales. After that, you have to put the sign of tilt. This is a sign of tilt. And where you are going to find this sign, you will find this sign on the, it's on the above of tab. Are you seeing the button tab on your system?
Yes, ma'am.
It's above that. So just press shift and
Yes,
that
ma'am.
button, you will get the tilt sign. And after that, just write C bracket start 1:, length sales. Now everyone has done this command. Now just see what this command is. This command says linear model. We are converting it into linear model. Now what I have chosen the file sales. I have chosen the file sales because I am working on this file. In sales trending, I am first working on the sales variable. So I have taken sales. Then I have put the tilde sign. If I am writing in a notebook, I'll write dash. That what I am going to convert sales, and C means your complete constant starting from the first length, that means starting from first variable till the complete length. If there are 158 entries, that means I want all the 158 entries to be detrended. So length means complete part of sales. Got it? How I got this? How I've written this line? This.
Ma'am, after trend, what you have written, it is minus or equal?
LM equals to, sir. So trend is just a name given. You can give any name. You can write X, you can write Y, you can write Z, you can write any name. It's just a name that I have given.
Acha, you have given it, I mean, it is not coming from...
No. I can write it X also.
Ma'am, in my case, every time sales trending is coming, not sales is coming. Sales is
Sir,
not...
that means you have not attached the file.
No, I have attached, ma'am, but
So
sales detrending is coming every time.
Sir, below sales detrending, there will be a sales part and some bar, pink color bar will be there.
Only sales detrending is showing me.
Sir, it will show. Now just press enter.
The same problem is for me also. It's only showing sales detrending.
That means you have not attached it, ma'am. If you have once you have attached it, you will find both sales and turnover over there in your files.
No, it is okay, ma'am. It is there. Sales and turnover is there, but sales detrending is showing only.
No, sir. Both. Once I complete this command, I'll commit back.
Okay.
Now, just see, once you have written this command, I press enter. On your environment window, you will see that the file is created with the name X.
Ma'am, I'm getting an error as soon as I press enter. Error in eval.
Eval?
I got it like this, same as yours.
Okay. So if you are writing instead of X, if you are writing Y, over here you will see the Y variable. So whatever name you are going to give it over here, you will get that name in your environment window. If I must have written trend, so the name over here will be trend. So it's just an abbreviation or name that I am giving.
Ma'am, was there initially before LMS test, was there anything else also that you installed in the library?
No. This is the first part that I have installed it.
Okay. Before ACF, PACF, you did not.
Symbol after sales.
After sales, that is a tilde sign.
How did you get this?
It's above your tab part. If you will see on your keyboard, are you seeing tab on the left hand side?
Correct.
It's above that. Just press shift button and that tab you will get this tilde sign.
Okay. Thank you.
Now everyone has done till here. Everyone has got this X in the environmental window.
Yes, ma'am.
Yes, ma'am.
No, ma'am, I have not. It's the same thing showing error in eval.
No, ma'am, even I didn't.
Where is that,
And that means there is some mistake while writing the command. I'll just put this command in your chat box.
No, ma'am, actually what you told to update the package, that I did, but it's not happening. So it's not happening with me.
Okay, let me write this in the command box. Now let's detrend it. Now detrend. Now detrend is equals to, now I'm saying how to detrend it. Detrend is equals to sales. Now my sales variable was there. From this I am giving the command subtract the complete trend. Now I make the trend with the name of X. I have captured the trend in the name of variable X. So I will say that subtract this trend from the sales so that my sales part or my sales variable will be detrending. So I'll write predict bracket start and my X variable. So now you will see on the environmental window, my dtrend file is ready. Now, if I'm going to plot this dtrend file, now you can check whether my file is detrended or not. Plot TS dtrend.
Sales minus predict.
Now see, my file is detrended. It's not taking the upward direction. My trend is removed.
Ma'am, the formula is actually not working. It says error. I mean, X is equals to LM sales.
No, sir, it will be working.
Ma'am, why this library LM test has been repeated?
I was just showing how to do it. You don't have to repeat it.
Ma'am, it is
I
detrended.
couldn't
but
understand this understanding of
the data?
detrend is equal to sales thing that you have written. I couldn't understand why we have done this.
Because we want to remove the trend. In the previous part, now see, this is my deterministic trend. I want to remove this trend that is moving upward. So if I have to remove this trend, so that means I have to detrend this series.
Yeah, got it, ma'am. So what we are essentially doing is X is the new variable that is being created. And so we are predicting sales basis X.
Yes, sales. I'm removing this trend from the sales so that my file is detrending. So I am predicting that this X variable that I have created is a trend. I have captured the trend. So I'm removing the trend from the sales file. So once I remove that trend from the sales file, my files will be detrended.
Got it,
I
ma'am.
have created one detrended file. Now I have plot this file. So once I plot it, my file becomes detrended.
Ma'am, what is this symbol after sales?
LM. LM bracket sales tilt. Tilt sign is there.
Excuse me, ma'am.
Yes.
Excuse me, ma'am. Ma'am, actually there was some problem on the part of me. Network issue was there, so I was not able to got it. So can you brief it again, if it is possible for you?
We go on at this speed.
What we have done, we have just learned how to detrend the files. And if you have missed that part, ma'am, I suggest you that you can just go through our videos because we will be providing the recording. And YouTube also, we have also given the live streaming on the YouTube. You can also go through that also. So because if I'm going to repeat again and again for each and every participant, we are not going to complete the syllabus that we have shown it to you. We have to work on it.
Yes, ma'am. Fine, ma'am.
This equation where we are creating X is equal to LM, it is basically we are identifying the trend through the
identifying the 10
through the package that is given.
Yes.
And then we are just eliminating that trend.
We are eliminating that trend from the sales variable. So I have given this name D trend. You can give the name X, Y, whatever you can name it.
So whatever, this is non-stationary data, though it is trend is removed.
Yeah. It's a non-stationary data,
but trend
I
is
have removed the trend. Now, if I'm going to test it, it will become stationary. Once you remove the trend, the data becomes stationary.
Okay.
Just a minute.
Can anyone tell me how did we attach the file in the beginning? Because I think I'm facing the problem because of that only. So
just write attach and it will give you brackets. Within the brackets, write the file name that you want to attach. So here it is sales underscore detrending.
Okay.
And my request to participants is that please ask limited number of questions, otherwise we will not be able to complete everything. So it's my request.
Okay. Now, any doubt in this detrending part and how we are going to plot it?
No, ma'am. Thank you.
Now,
please continue.
Now, can you try on your own for turnover? Let's say have a 2 minutes time so that you can try on your own on your turnover. So now, whenever you are detrending the turnover, first of all, just test whether the turnover, this variable is also a deterministic trend or not. If it is a deterministic trend, then try to detrend this file. And once you detrend it, you will also get the similar type of graph.
Ma'am, what is the syntax? LM sales tilt
Till
C.
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 I have written the syntax in your chat box.
Ma'am, I have a conceptual query, please, if
Yes.
possible, ma'am. We said that deterministic trend is when, the variation over periods of time is constant.
It's
So
near
now
about
when we have
constant.
detrended, ma'am, then also the variation is similar. Only
But it's
the
not
upward slope
increasing.
has gone.
Yes.
Only the upward slope
Yes.
has gone.
Yes.
So still, I mean, if we talk about deterministic and stochastic, then it is
Now
still
I have not removed the determine. I have just removed the trend from this.
Oh, got it. So we are saying still the variation is still constant, but it is still, it is not upward slope.
Yes, yes. I have taken it to the, I have removed the trend from this.
Got it.
Ma'am, if we would have removed the constant, then we would have been able to forecast only. So we want the determined part to stay.
We just have to, determined part can be there. We are just to remove the trend part from this.
Only has
so I have removed the trend part. Now in irregular variations also trends are there. So we are going to remove that trend from that also.
Ma'am, is there any undo thing in this R studio if we give a wrong command by mistake?
Ma'am, you just enter it.
Enter it?
Again. Enter it again.
Okay.
And
Double enter.
Yes, yes.
Yes.
Ma'am, it
No. Retry it.
What?
Error
Retry.
in eval.
So many people
Pre-diverse
are saying, so I'm not
data
able to gather.
environment object sales not found.
Sir, please, can you let me ask my question?
Yeah.
I just asked, ma'am, please answer.
Ma'am, I didn't hear your question.
Ma'am, I said if we give a wrong command by mistake, is there any undo thing in this R studio?
No. There is no undo thing. You can just remove the complete files. You just press Ctrl+L. Your window will be clean.
Okay.
Ma'am, it is saying object sales not found.
Sir, maybe there is some problem with your command, or maybe attaching the files.
Ma'am, for the turnover.
Yeah, ma'am.
Sorry to interrupt you. Please, you continue.
I'm just saying, if you have still any doubt, we can take the doubts at the end.
Ma'am, can you scroll the screen? Console part आप screen एक बार scroll करोगे, एक बार ऊपर पता चल जाए कि क्या किया हुआ है बस.
I have just this. You want to see this?
आपने यहीं से start किया था मैम ACF
Yes. I started from ACF.
Ma'am, just a small query here that before detendering this turnover, do we need to check for ACF and PACF?
No. Once you plot it, you will find whether there is a trend, it's upward going or not. Trend is there or not. In stochastic trend, sometimes it will go up, then down. I have shown you the graph of the share price. So if you will attach the file of share price that I have given it to you, that is not a deterministic trend, that is a stochastic trend. Sometimes the price moves up, sometimes moves down, then again up, then again down. So that is your random walk, or you can say stochastic trend.
Okay.
So for turnover, stochastic trend also we will have to detrend it like this.
Yes, but for that we not name it as a detrend. We remove the trend. So stochastic trend also has to be detrended.
Now we will show that over here in this class.
Yeah. Now let's say just attach the file. Share price. Now everyone has attached this file. Now just see the graph. We have seen the graph yesterday also. Now see the graph. Now again trend is there now, but it's a stochastic trend. Sometimes it's moving up, down, but the change is not constant. Everyone got this graph?
Ma'am, once we attach it yesterday, do we again have to attach it, or yesterday's
yes.
attached?
No.
Only
Every
one.
time.
Every time.
Yeah. Because see, last time in class, yesterday's class also I told you that whenever you are going to read any book, or let's say you are at home, you want to open any book, so it's not remain open. You are going to close it, put it in the shelf, and every time you are going to work on that book, you have to take it out, open it, and then work on it.
Okay.
So same is with the art.
Ma'am, can you scroll up your console? After attach, there is view, and then
no, just attach it. Attach your share price. I've just attached the file.
Ma'am, I have already attached it, but I'm not getting this.
No,
Yes,
you won't
ma'am,
get
I
it.
also attached, but not getting this.
You won't get it because I have attached number of times. That's why it's showing that it's already attached and the same abbreviations are there. So it hardly matters. So I just make the plot.
Ma'am, you gave view command also, I think. View.
No. View command. How you are going to get view command? Just click on this share price. If you will click on this share price, you will get the view command.
Okay.
Now, are you getting this plot? Are you getting this? There is a stochastic trend in this?
Yes, ma'am. Yes, ma'am.
Now, how to remove this? And that is, we name it as a stationary. Now, whenever we remove the stochastic trend, we remove it by differencing. Now, there are two parts of differencing. One is log part. That means we have to find the returns. And one is simple differencing. Simple differencing means year 1 is subtracted from year 2, year 2 is subtracted from year 3, year 3 from year 4. So we are finding what is the difference between it. Now, whenever you will be working on the price part, for example, I have taken share price. So in this case, we will be working on the returns. We have to take log differencing. So that means I can write it over here. If you are working on the price, take log differencing. And if you are not working on the price, for example, you are already working on percentage. So take your simple differencing. Now, let's say how we are going to work on log differencing and simple differencing.
Ma'am, log differences, we take the logarithm of the numbers, and then we do the difference.
Yes.
Ma'am, please scroll your screen so that I can see the earlier commands.
I have not written any command.
Ma'am, I am little lagging behind. I'll just copy the commands and write.
Don't worry, I'm going to send all the commands by the PPT. Okay, can we start?
Yes, ma'am. Yes, ma'am.
Now,
Yes, ma'am.
again, now I have to remove this trend over here. So first of all, I'll show how to do differencing. But since this is a share price, so I'll not suggest as a researcher that you should go for a differencing part because the result won't be accurate.
Ma'am, why did you use a view command? View was for what, ma'am?
View was just to see that if I use this view command, I'll just go through this file over here. That way I can see this file. Okay. This command has no role to play.
Okay.
Now, first of all, simple differencing, you can give any name. So for simple differencing, I am naming DN225.
So if not coming, then we have to install some pack.
Which thing, sir?
Ma'am, if view is also not coming, so we have to install some.
No, we don't need it. It just to view it that you can see the file is already there in your system. We don't need this file.
Ma'am, can't we detrend it in a similar way like we did previously?
No, we can't do it because that was a deterministic trend and this is a stochastic trend.
Okay, ma'am.
So in both the ways, we have to remove differently. Now, first of all, I'm telling you how to do the simple differencing. But simple differencing is done when the data is in percentage or when it's not in price. If the data is not in price, you can use simple differencing. If data is in price, for example, you are taking the sales. Sales is always in price. Amount is there. So go for log differencing. Calculate the returns. So first of all, I'm just giving the abbreviation DN225. Why I have taken DN? Because for D, I have used the abbreviation as simple differencing. And N2 to 5, I have used that I am doing the simple differencing on this data. So just write diff and the file name. File name is N2 to 5. Now, in the environment, you will see the file name is created, DN22 file. This file is created, and this is in this file, the trend is removed, but the simple differencing is there. Now, let's see how we are going to do log differencing. So, just to make the different names so that we cannot get confused, so I'm just writing RN225. I'm just giving the name. You can give any name. Diff. Now what I am doing, for what I am finding the difference, I am taking the log difference. So diff log N225. So now what I am giving the command, I am taking the difference of log. Now see, the file is created RN225. Now let's plot it. Plot.ts. And now I am going to plot this part, RN225. Now see, it's removed and the data becomes stationary. Now what is stationary, that we are going to come. Still here, any doubt how to detrend the files and how to
I have a theoretical question actually. So basically we have detrended the data.
Yes.
The trend, I mean, you know, the graphs are different in the respect that there is normality in this graph and it was unstationary.
No. Normality won't be there. Now I can show you. Just type hist. I'm just showing the histogram of RN225. Now it's not sure that the normality is there. Now, yes, its normality is coming on this data, but it's not confirmed that your data will be normal.
Okay.
Time series does not say that you will work only on normal data. We can work on non-normal data also, on the skewed data, on the, you can say negatively skewed, positively skewed, we can work on that.
So ma'am, how are we reading this graph that we found after detrending? I mean,
now,
how are we interpreting?
The interpretation is that the stationary part is there. There is a constant mean in all the ways. In all the time period, the mean is constant. You are seeing that the figures, the return is going up, then going down. It is coming back to the zero.
Its mean.
So it's a mean is constant at all the variation. At all the time period, your mean is constant. When the mean is constant, we can determine the future. If mean is not constant, how can I determine? But in this graph, now see, if I'm going to calculate the mean after every regular interval of time, my mean will not be same.
Right. Yes.
Over here, mean, let's say the figure is 10, 12, my mean is near about 10. If I'm going to say figure is 50, 60, I'm going to take the mean of 50 and 60, it will be 55. So mean is not same. So in stationary, we should have a constant mean. Every time the mean is same. Now I have converted the data into the stationary. It's going up, going down. So the mean is, it's mean reverting. We can name it as a mean reverting. It's coming back to zero mean. So my mean is constant in this. So once I made the mean constant, my model will become the smooth.
So ma'am, in R, it is not that we get to know whether the autocorrelation is there or a deterministic.
No.
What I'm trying to say is that we are not able to get it through values, numerical values. It's only through pictorial values that we get.
Yeah, that's why I told you, first of all, make the graph so that you can imagine what the graph is going to tell it to you.
Okay.
Now,
hello, ma'am.
So ma'am, on the basis of this, diagram, we can make some forecasting.
Yes, we can make some forecasting.
Okay, ma'am.
Ma'am, which one should we prefer, simple difference here or log?
Ma'am, if it is a price, now I am working on the share price, so you have to take log, you have to take return differencing only.
Because you formed a file DN225 as simple difference also.
that is just to show it. But if I'm going to create the model on this file, my model won't be accurate.
Okay, so we should take logs.
If the price are there, if you are working on the price file, take logs. If you are not working on the price file, take simple differencing.
Okay, thank you.
For example, if I say that what will be the COVID cases, I'm working on the COVID cases, or COVID cases from the first day, or how many deaths are there till date. So death and cases are not the price. So I'll take simple differencing.
So for stock prices, you will always take log.
Yes, yes. For if I'm comparing that if the COVID is there, cases are there, whether the COVID cases are going to impact the share price or not. So if when I am converting the share price, I'll take the log differencing. And when I'm removing the trend of the cases, I'll take simple differencing. So it depends on the variable, which variable you are taking. If it is a price variable, go for log differencing. If it is not a price variable, go for simple differencing.
Thank you.
Okay, till here.
I have one question, ma'am.
Yes.
Do we have any reference for this, that which difference is to be taken in the case of price and in the case of
So
percentage?
for that, you can go for literature review. Once you review it, all the literature, so you can give the backup of the literature review only.
Okay. In any book where it is written?
It's not written in the books.
Okay.
It's our literature that shows us. So you can give the backup of the literature. So as per the literature, we have to detrend it for the price with the help of log. And if it is not a price, if it is already in percentage or cases are there, deaths are there, simple figures are there. So we have to take the simple differences.
Okay, thank you.
Now, can we move to the descriptive statistics now?
Yes.
Ma'am, RA 225, that file I'm not getting. I have got.
And that is created. It's a created. Instead of R225, you can give any name. You can give X, you can give Y, you can give any name. So
but how can I create that?
Just write X. Okay, I'll just give you another file. Just write Y. Y is equal to
Hello.
div.
Hi, ma'am. Ma'am, if a series has a trend that is stochastic or deterministic, then series is stationary or non-stationary?
Non-stationary. But sometimes you will also find that that series is also stationary, but we have to remove the trend.
Okay.
But it will be 99.9%, it will be non-stationary. Now just go for div and then write log. Once you write log, in the drop down, you will get log. Click on that and write whatever variable. For example, I want to remove the trend from BVSP. It's BVSP. It's automatically there. Just click it over here. My variable is created. My file is created in environment Y. Now, if I'm going to plot Y, plot.ts and Y, now you will see my data is detrended, or you can say my stationary data is there.
Okay, ma'am. Thank you.
Okay. Now let's start with the descriptive. Now let's take 1 or 2 minutes break. Okay.
Can someone tell me that I just...
Okay. Anu ma'am, are you there?
Yes, ma'am.
Okay. Can we start with the
Certainly. Certain. Just give me 1 minute.
Yeah.
Give me co-host, right? Gaurav, please give me co-host, right? And let me start it.
Divya, are you there? Divya, can you start?
Can someone tell me that I just differenced the series and plotted the BVSP series, but it has not been differenced. That is, its mean is not constant. We got the same result.
Himani ma'am, you have to stop your screen so that I can start it. Thank you, ma'am.
I've got it. I've done.
Divya ma'am, you are not audible. Ma'am, you are not audible.
Everybody, it is now time to welcome our second resource person of the day, Dr. Anu Bhardwaj. Dr. Anu Bhardwaj is an assistant professor in the Department of Management Studies, TIMS Vasant Kunj, New Delhi. She is an MBA, MPhil, and doctorate in marketing from Aligarh Muslim University. She has 16 years of teaching experience and has published various research papers in journals of national and international repute. She has received a research grant from ICSSR on project of wash attitudes in 2019, and she has organized and attended various seminars, conferences, and workshops. Her research interests are CRM, CSR, branding, and structural equation modeling. In this section, Dr. Anu Bhardwaj is going to discuss descriptive statistics with all of us. I welcome Dr. Anu Bhardwaj and I request her to take the session forward.
Thanks, Divya. Well, good morning, everyone.
Good morning.
Good morning, ma'am.
Morning.
Good morning, ma'am.
Very good morning, ma'am.
Very good morning, everyone. So I've been given a task to discuss the descriptive stats with you. Basically, most of us are quite familiar with whatever we are doing and we are going to discuss today. So let's have more clarity on certain concepts. So primarily what we are going to do is we are going to understand what is mean, median, mode and their relevance. We'll also be talking about dispersion, range, standard deviation, and towards the end we'll be talking about normality. And we'll be doing the same with the help of Excel, wherein we'll be plotting everything. We'll be making a histogram, and we'll be calculating the descriptive stats on Excel. So the whole 1 hour lecture is divided into two parts. First the theoretical and then the practical. So whatever we are studying here, we'll be relating with that. So I think we all know what stats are. So initially, stats is basically a very important tool. In fact, over last 20, 30 years, statistics has got the kind of, appreciation and acceptance that, it has got today. It's all about, when we collect information from the mass, from the population or a part of population, what we call sample, then the data is voluminous. And in order to bring that data into some quantity, into some particular numbers or digits with which we can, go for further analysis, that basically is stats. So stats basically helps us in summarizing the data. It gives us a summarized form of data. Otherwise, it will be very difficult for any, researcher to, work on a data of 10,000, 20,000, 30,000 odd units. By just simply selecting and putting a formula and coming to a mean, a single value can talk about the entire data set. So this is the relevance of the descriptive stats. So statistics basically helps in summarizing the data and understanding the overall, data patterns, like what is the frequency, how the data is skewed, what kind of variation exists. So everything we'll be able to find out once we are putting statistics on the data. Now, basically, stats is divided into two parts, that is descriptive and inferential. So descriptive stats is wherein we describe and we summarize the data. And under descriptive, we primarily do three things. We go for center tendency, we go for dispersion, and we go for skewness. As far as the inferential stats is concerned, inferential stats, guys, just a second. Sorry for the inconvenience. Now, inferential stats is basically about, when we are trying to, relate that whatever, values we have got, how significant difference is appearing in a group or among the variables wherein we have collected the data. Inferential stats is higher order stats, and this can be done only once we are doing the descriptive statistics. Here we basically do a lot of hypothesis testing. We apply chi-square, T, ANOVA, F-test, and there are many other tests which helps us in inferencing the meaning out of the information that we have collected. So all the hypothesis testing and everything becomes a part of inferential stats. But for this particular lecture, for this particular FDP, we are only concerned with descriptive. So let's go with descriptive ahead. Now, whenever we have a data, what information we need from the data is that what kind of shape will it form once we plot it on a graph, or where exactly is the center of the information lying, or what is the spread, what is the minimum maximum value, and how the spread of the data is. So any statistician or any researcher, when once the data is collected, is very much interested in understanding the shape, the center, and the spread of the data. And all these three things can be calculated or can be seen with the help of descriptive stats. In fact, shapes can be done with the help of graphs. For that, we'll be talking about histograms. For center, we'll be using the mean, median, and mode thing. And for spread, we'll be talking about the standard deviation, variance, followed by skewness and kurtosis. So all the three things, that is shape, center, and spread, can be understood with the help of descriptive stats. Now, a common example of descriptive stats is, suppose we have collected a data from a class and we are very keen in understanding that what are the age of different people, or which area they belong to, or what is their gender. So once we collect the data and once we analyze the data, we can basically come out with the information. Like for an example, in a class of 60, 50% of the people are of the age of say 12. Another 50% people are of the age of 13. Now, how can I say that? That can be done only with the help of descriptive statistics, when we basically work out with frequencies and other things. So as I said, it is a summarized information of a voluminous data. So whatever information we need on various kinds, on various things, descriptive stats is very much helpful. Now, coming to frequency distribution, we all know what frequency distribution is because it's the first stage of statistics. When we have data and when we have voluminous data, we need to basically find out that how many times a particular response is repeating. And that is what frequency is. Like for the convenience, I've shown you two examples here. In the first example, if you say, we are saying that the height of the students, and we have mentioned the height, that is 139, 145, 150 centimeters. And then the frequency is telling that how many students are falling into this category. So one student is having a height of 139, two people are having height of 145, two are having 150. So this is basically frequency tables. Frequency table basically helps us in understanding that in what categories, how many people are falling. In the other, I have categorized it and we have made a class. This is known as class. So first class is 10 to 19. Second class is 20 to 29. So 0, that means nobody is falling from 10 to 19, but there's one person who's falling from 20 to 29. And likewise. So frequency distribution is basically a method through which we assign category to different classes. This is the most basic form of descriptive stats. And with this way, we can easily calculate the percentage from the information that we have collected. Now coming to the central tendency, which is the most important thing here. Now, when we talk about central tendency, there are three main things in central tendency. That is mean, median, and mode. Now, what is mean? Mean is basically the average. And as ma'am was telling, and as whenever you must have applied stats, you must have seen that mean is something which is important and is required to calculate most of the higher order stats. You talk about standard deviation, you talk about anything, you need mean value. So what is mean value? Mean value is an average value. So we sum total all the observations and we divide by the number of observations. But the problem with mean is that it gets affected by outliers. So now what are outliers? Outliers are those extreme values that can affect mean. So if I explain you here, suppose I have a value of 1, and then I have a value of 2, then I have a value of 3, and then I have a value of 4, and then 5, and then 5, and then I have a value of say 18. So now if I talk about the mean value, this 18 is going to affect the mean value. It is going to take away the mean from the real mean because this is the outlier. And most of the statisticians, they give methods of handling these outliers, because these outliers, they affect the mean directly. And whenever there are outliers, this basically affects the overall evaluation and the understanding of the data. So whenever we go for descriptive stats, one of the important things that we do is we try and find out the outliers, and then we treat the outliers accordingly. Either we remove it from the data, or then if it is not possible, then we can go to the alternate method. We can go to medium for understanding things rather than using mean, because median is something which doesn't get affected by outliers. So outliers are something which are essentially important for the quality of research that we are undertaking, and it is something that affects the mean, and this is the most problematic thing as far as mean is concerned. Now, the second thing is the median. Median is the mid value. It basically divides the entire data set into two equal halves. So this is the mid value. So whenever we apply median, what we generally do is we put the entire data set into a sequence in an ascending order, and then we see the mid value, and that becomes the mean value. So even if you have an outlier, median value is not going to get affected by it. So that is the relevance of median. So in case you're not able to get the rectification of your outliers and your data is of such kind and your research is of such kind, then many researchers, they come to median. Otherwise, the most commonly used method for any central tendency and arithmetic thing is the mean thing. So it is the 50th percentile. This is also known as 50th percentile, as it divides the data into two halves. So if you look at this, this is an example of 13 students. So I've given them into a sequence in the ascending order from 89 to 131, and the mid value becomes our median value. Sorry. Now this is what I was saying, that even if we have an outlier, the mid value is not going to change. The last digit is as per the series, or it is very much different from the series, is not going to make any effect on the mid value. So hence, the median is not affected by the outlier thing. Now, when we have a symmetric data, now what is a symmetric data? Symmetric data is a data which is perfectly, bell-shaped curve. And if we divide it from the mean, it is exactly divided into two halves. That is what symmetrical data is. So now if we have a symmetrical data, then generally the mean and median are same. But if the data is not symmetrical, which means it is skewed, either it's a positively skewed or it's a negatively skewed, then there's a difference between the mean and the median. Generally, the median becomes the midpoint and the mean moves towards the degree where the skewness is there. So if it's a positively skewed, it will move towards positive side. If it's a negatively skewed, it will move towards the negative side. We'll be going through the skewness, and then you'll be able to understand it better. So median does not get affected with the skewness of data as well, because it is the midpoint, it is going to remain the same. But mean is going to get affected with the skewness of data. And this skewness of data is because of outliers also. Now, the next is mode. Now, what is mode? Mode is basically the value which appears most times. The maximum number of times a particular value is repeated is called mode. Now, in a normal distribution, which is a bell-shaped curve, it's a unimodal distribution. That means there can be only one mode. You cannot have more than one mode. If you have more than one mode, then your data is not normally distributed, because then it will not form a perfect bell-shaped curve. Like if you see here, 109 is repeating 3 times. So this becomes the mode. If I say 110 is also repeating 3 times, if I add another 110 here and another 110 here, and then that means these both are modes, because both of them are repeated 3 times. So in case we have such kind of scenario, then your data is not normally distributed. You cannot apply all the stats that is applied to the normal distribution. So when we calculate, we should calculate mode also to understand that how many modes we have. We need to have a unimodal data to have a normal distribution. Now I'll give an example here where mode is used. Mode is basically used, and it is very much used in retail sector. Or when we want to understand that what is the frequency, the highest frequency of a particular article which is moving. Like for an example, you're managing your inventory in a retail outlet, and suppose you have, you are maintaining shirt, a formal shirt. Then if you go for mode values, mode value can tell you, okay, the 40 size shirt of white color is something which has the highest frequency. That means this is the shirt which is mostly picked. So when you are, putting your inventory and you're reordering things, then you can manage your inventory accordingly. So mode is very much used by the people who are actually dealing into the numbers, but who are dealing into inventory management, and those who want to see, suppose I want to see which salesperson is doing best, then I can see, okay, how much sales he is doing, who's the maximum performer, and how many number of times he's performed the best. So for monthly best performer, you can use mode. For yearly best performance, you can use mode. So mode basically used when the frequency is highest in a particular thing. So this is about mode. Again, as I said, mode, mean, median, and mode, they lie at the same point if the data is symmetry. And if the data is symmetrical, that means it's perfectly normally distributed data, because your mean is equals to median is equals to mode. But if the data is skewed, then your the entire 3 points, they are different. Your mode will be the point where your peak will be. Your median will be the mid value, and your mean will be the different. So wherever the skewness is moving, like in this case, it's moving towards the right side. Now, if it is moving towards the right side, the median and the mean is shifting towards the right. Had it been a negatively skewed data, it would have shifted towards the left side. So wherever the degree of skewness is, your mean and median will be moving towards that. But if it's a symmetrical data, like here, it'll be in the center. Then is dispersion. Now, it is very important to understand the dispersion thing. Dispersion basically tells us that what is the degree at which the data is dispersed from the mean. What is the range? How your data? What is the shape? How spread your bell-shaped curve is? That is basically dispersion. Dispersion can be done in 3-4 different ways. Range is one of them. Interquartile deviations are one. Variance, standard deviation. So these are the various methods through which we can work out our dispersion. Now, range is the highest value, that is the largest value, minus the smallest value, and this gives the range, that is the spread within which your data is spreading. So when we'll be going to Excel, and when we'll be going to work out the descriptive stats, there the range will also be calculated automatically. It is automatically calculated by the Excel. Interquartile deviations are basically when we break the entire dispersed data into various quartiles. So we can have first quartile, then we have median, then we have quartile 3. So this is basically dividing the data into various quarters. So like for an example, 50% is the median, which divides the data into 2 halves. 25 percentile is basically that divides the data into 1/4 and 3/4. So like here, if you see, if we go from 0 to this side, then this 25% is dividing the data into two parts. The first part covers the 25% of the data, and the second part covers the 75% of the data. The second generally division is done at the median level, which is 50%. And the third quartile is 75%, which again divides the data into 2 halves. The first part covers the 3/4, that is the 75% of the data, and the last part covers 1/4, that is the 25% of the data. So, different ranges are calculated to understand that how data is dispersed. Now, variance. Variance, as I said, it is the spread, how much your data is spread. So there are 2 diagrams, there are 2 demonstrations that you can see here. In the first, you can see the spread is a little wider. That means the shape of the bell-shaped curve is a little flattened. So we can say here the variance is more. That means the data is dispersed more. But if we see here the dispersion is less. That means the data is dispersed less. It is more closer to mean. The difference between the mean and the other data is very less. And that's why it is nearing about the mean value. But here, the difference between the mean value and the actual values are different. And that's why there's a higher degree of dispersion. So variance and standard deviations basically helps in understanding that what is the average deviation of a data from the mean. So this is another example. Suppose we have 25 values and the standard deviation is 3 and standard deviation is 6. So if the standard deviation is 6, that means it is moving 6 points from the center, positive, negative. And this is moving 3 points from the center, positive, negative. And then if we draw a bell-shaped curve, you will find out that the bell-shaped curve is a little less flattened in case when the standard deviation is less, and it is most flattened when the standard deviation is higher. So standard deviation basically tells the dispersion. And what if there's no standard deviation? If the standard deviation is 0. So if the standard deviation is 0, then that means it is not a variable, it is a constant. Whenever there be a variable, it then needs to be a standard deviation. Higher the standard deviation, higher the dispersion. Higher the dispersion, higher the distance between the mean value and the other values. Now, normal distribution. What is normal distribution? Normal distribution is basically how your data is spreaded. When we plot the data on a graph, then how your data is plotted and what kind of shape it takes. A normal distribution curve is a bell-shaped curve. This is a perfect bell-shaped curve where there is no skewness. The data is symmetrical. And when I am saying data is symmetrical, it means that the mean is equals to median is equals to mode. That means there is no skewness, and this is a perfectly normal distributed data. Any statistics can be applied on this kind of data. But generally, we see that there is a degree of skewness. There is a degree of skewness in the data that we calculate. This perfect situation is not always possible, and that is why there is a degree of skewness that is calculated. And different authors have given different benchmarks. As per Carl Pearson, plus minus 1 is the range within which if your skewness is falling, it is a normal distribution. But if you apply SEM, that is structure equation modeling, plus minus 3 is taken as the standardized threshold within which the data should fall in order to be considered to be normally distributed. So it is not that we can eliminate the fact that there will be no skewness in the data. Your mean, median, mode will be perfectly, the same. There can be a variation, but if that variation is within the acceptable limit, the data is considered to be normal. And that acceptable limit is -1 and +1. So if your data is falling between -1 and +1, if your skewness value is coming between that, then your data is considered to be normally distributed. When we'll be doing in Excel, you will be seeing that, what skewness value is coming, and then accordingly, we'll see whether our data is normally distributed or no. Okay, so a skewness formula is mean minus median upon standard deviation. Whenever, the data is moving towards either which size, we call it either negatively skewed or we call it positively skewed. So let's just see through these curves. Now here, if you see, the bell-shaped curve is not the perfect normal bell-shaped curve as I showed you here. There is a difference, and the difference is that it is moving towards the right. This curve is moving towards the right. That means the data is skewed, positively skewed, or what we call rightly skewed. Here, the mode is here, median will be somewhere here, and mean will be somewhere here. That means your mode will come first because this is the point where mode lies, and then median and then mode. So the median and mean are moving towards the positive side because the data is positively skewed. Now, if we talk about the negative skewness, then here it is going towards this side. That means here, this is the mean, this is the mode, and your median and mean will be lying towards the negative side. So this is called negative skewness. I was just reading, and I came to know that in most of the situations, the data is positively skewed. Why so? I can't say, but yes, in most of the cases, if you apply the skewness thing and if you see the data and the degree of skewness, in most of the cases, the data comes out to be positively skewed. Then is kurtosis. What is kurtosis? Kurtosis is the peak value. That where is your mode line? What is the height of your curve? Now, if your height of curve goes higher, then this portion will become narrower. you know. So and this is because of the fact that the normal distribution curve is a density curve which covers 100% area. So if you are if the peak is high, then obviously this needs to get shrinked, and if the peak will come down, this needs to get broadened, because the entire data is to be commutated within that. And that is the one of the property of the bell-shaped curve, that it is a density curve and the total area is to 100% is to be there. So either which ways it will be adjusted. So kurtosis, basically the value is 3. So it is said that K is perfect when it is 3. If it goes above 3, then your peak will go higher. It become leptocritic. If it will come below 3, then your peak will come down and it will become more flattened curve. And then it become platykaryotic. So basically, kurtosis will tell us what is the peak, what is the highest, what is the mode value, how your data is lying towards the mean. So here, if we see the mean is really at top, and all the data is shrinked, and it is coming more around here. And here it is getting more dispersed, and so data can be away from the mean. So the ideal value of kurtosis is 3. Okay. This is again, as I said, this is a perfect bell-shaped curve, which means skewness is not there. Kurtosis is perfect 3, and mean, median, and mode is centrally aligned. That is, they are equal. So if anybody asks you what are the normal distribution, what are the 3 important things, then these are the 3 important things. Skewness, kurtosis, and the mean, median, mode should be perfectly aligned so that the data becomes symmetric. Now there is another normality rule, which is generally known as 68, 95, 97, 99.7 normality rule. Now, what is this? Let us explain. You'll be able to understand normality well. And this is the last thing, and after that we'll move to the Excel thing. Let's presume that we are measuring the height of an average Indian. So when the height was measured, the average height came to be 5.5. This point is extra. 5.5 is the average height. Now the first standard deviation is this is basically first standard deviation, second standard deviation, and third standard deviation. Now this is mean value, this is mu. It is said that if your standard deviation is 1 plus minus 1, that means your values can fall somewhere between -1 standard deviation to +1 standard deviation. If the standard deviation is plus minus 2, then your values will fall between this point and this point. That is -2 and +2 standard deviation, and -3 and +3 standard deviation. Normality rule says that if you go by up till 3 standard deviations plus minus, 99.7% of the data will fall into your normal curve. 99.7%. How? See, if the average height of an Indian is 5.5, and if I say, okay, I'll be taking only one standard deviation, then plus 0.5 and plus minus 0.5, if I add, then this becomes 5 feet and this becomes 6 feet. If I another go to -2, this becomes 4.5 feet and this becomes 6.5 feet. And similarly 4 feet and 7 feet. Now, if you see as per, and this is done with the help of Z scores, Z formula is applied in order to calculate this, and this whole thing is done with the help of Z score. So if you see, 68% of the people that we are collected data from will fall within the first standard deviation. That means their height will be between 5 feet to 6 feet. If I add another 1 sigma, that is I go up till 2 sigmas, 2 negative and positive standard deviation, then another 13.6 and 13.6 will be added. That means 95% of the population will be covered if you take deviations up to 2 standard deviation up to 2 degrees. And if you take it up to 3, then this goes to 99.7. Now you can say how this 34%, how this 13% is calculated. This is calculated with the help of Z-score. And this is the normality rule. So it is said that if you go and if you take your data up to 3 degrees standard deviation, then 99.7% of the people will fall under the normality range. Only 0.3% are the people who are outliers, who will not fall into these categories. And for them, we are actually not worried, because when we go for research, we generally go for averages. We don't go for outliers. So this is the normality rule. This is the Z score with the help of which, that particular percentages were calculated. So with this, descriptive stance is over. There are 2 parts, as I said, central tendency and, variation. Now what we're doing is we'll be shifting to Excel. So I'll just stop my screen share and I'll come down to that. Himani ma'am, have we shared the data with them? Can anyone please unmute and tell that is the Excel data for descriptive being shared with you?
Yes, ma'am. Yeah, it has been shared yesterday.
So you can please open your files and you can open your Excel. Meanwhile, I'll also start.
Yes, Anu ma'am.
No, ma'am, I was asking ki Excel wala data has
Yes, I have shared. I have shared.
So just give me 2 minutes, we'll start. Please open your Excel file, the data file that has been shared with you.
Can you name those files? What were the names of the files?
I'll tell you. Just 1 minute.
Data set descriptive.
It is data set descriptive. All right, so this is the sheet that has been shared with you.
Yes, ma'am.
Okay, let's start the descriptive stats on Excel. Before we start, let me show you what we are going to do. So this is what we are going to do. We'll be using this data, we'll be calculating percentiles as I showed you there, 25, 50, 75. We'll be creating a frequency table. We'll be talking about descriptive stats, and we'll be creating a histogram. So all these things will be, and here only skewness and kurtosis values will be coming. So this is the output that we'll be having, and now we'll work on a plain sheet. So I hope everyone has opened the sheet. And on the data, when you go on the data.
Can you hold just a second?
Yeah, sure.
The file is opening, ma'am. Thank you.
Sure. All right, so I just want everyone to please check that once you go on data, you should have data analysis tool and data analysis here. In case it's not there, then we can, I can tell you how you can, actually bring it here.
Yes, ma'am. Please, could you please tell us how to get that over there?
Yeah, sure. Just a minute. Now, what we need to do is, you need to go to File. Just a minute. You need to go to File, Then you need to go to more.
Ma'am, it's an add-on.
Yeah, it's an add-on.
Yes, ma'am.
Won't you go to insert?
Options.
Go to insert, I think.
For Windows, we have to go to options, I think. Yeah.
But here, I think we are
In file for Windows, just a second. I am going through Apple. Just let me tell you in Windows how we are doing it.
Ma'am, this is the option.
Just 1 minute, guys. Let me tell you exactly where it is. You need to go to file and you need to go to options. In options, you need to go to add-ins. In file, you need to go to options. In options, you go to need add-ins. In add-ins, you need to check the analysis tool pack. And VBA, and then you have to click OK. I think everyone has got that now. Just go back to data and check. You'll be having a data analysis tool right here, like you can see on my screen.
Yes, ma'am, we have got.
Thank you.
Ma'am, there is only one data analysis.
Ma'am, I have
tools
done
is
but
under
not
that
getting.
only.
Data analysis is enough. Ma'am, you need to, if you're using Microsoft, then you need to please go on file. And under file, we need to go to options. And in options, ma'am, you need to go to add-ins.
Ma'am, I have followed all the commands. Still, data analysis bar is not showing.
Ma'am, this is the way that we do it. Rest all have got it.
Please tell me about Apple as well.
Apple, you just check. I think it is there. You just go to data, it will be there.
Ma'am, it is analyze data in Apple. You can see analyze data.
You have take this analyze data. Just click analyze data, analyze toolback, and OK.
Why I'm not getting, I'm not understanding. I have followed all the commands.
Gaurav, are you there?
Yes, ma'am.
Gaurav, ek bar I'll stop my share because you must be working on Windows, na?
Yes, yes.
Can you please show them?
Just let me check, ma'am.
I'll stop it because I'm not working on Windows, so I can stop my share. Shall I, Gaurav?
Yes, ma'am.
I'm stopping my share. Ma'am, sir will tell you, he'll show the live demonstration. Gaurav, I think you can now pitch in, please.
Okay, ma'am. Thank you.
Most welcome, ma'am. Gaurav?
Just hold on, ma'am.
Yeah, sure.
Options.
Hello.
Can you please mute your phone? Can you please mute yourself because there's a lot of disturbance, please?
Anu ma'am, may I start?
Yeah, please, whosoever is sleeping.
Yeah, ma'am, Pooja, ma'am, the same.
Yeah, please, Pooja.
First
Agreement.
we'll
No
go
constitution
to
board
file. Then we'll go to options. After that, we will go to add-ins here. Okay. After add-ins, we will be having here Excel add-ins. We'll click OK.
Pooja, you have not ticked the analysis tool back. You need to go back again. Option पे जाइए. Option में add-ins में जाइए. Add-ins में ये जो analysis tool pack है ना, ऊपर 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 ऊपर, हाँ इसको क्लिक कीजिए. Analysis tool pack को भी check कीजिए. Next वाले को भी. Both you need to click. इन दोनों को add करना है हमको.
Ma'am, we need to do it by one maybe.
Okay.
I'm not able to select it.
Press the control.
Select करके shift दबा के नीचे वाले को दोनों को एक साथ select करके देखो हो जाएगा.
No, I'm not.
Okay, then do it.
You need to click on Excel add-ins. You need to click on Excel add-ins in the drop-down menu.
Okay.
Now you click on it. Go for go.
Yeah,
click on go, and then you need to. Then you
select
need to check
this.
First and
analysis.
second.
Yeah.
Yes. Now okay.
Then okay.
Ma'am, give me 2 minutes for doing it.
So here in our data tab, we are able to see this data analysis part.
I think everyone has done that now. Thank you, Pooja. You can stop your share.
Yeah, it's showing.
All right, so
I'm done.
let's start it now. So the first thing that we are going to do on this data is the descriptive stats. So straight away go to data analysis and choose the descriptive stats part and click OK. Now here, because I've already done it, now this is a kind of box that must be generated. Now what we need to do is, because we have the choice of label in first row, we have to choose the entire data set. That is the marks of the students. Basically, it's a data wherein students have been marked. So these are the marks. We have to click the marks thing. So click on the input range. I hope everyone is with me.
Yes, ma'am.
Then please select the entire data range. It will be appreciated in case
with the heading of marks.
Yes, ma'am. We can do the heading thing because if you I just need to request one thing. There are some participants who are on unmute and they are there's some disturbance because of them. So if you are not discussing something related to FDP, it will be appreciated if you can please mute yourself for the convenience.
Sorry, ma'am, it was by mistake.
No, it's okay, ma'am. Please don't be sorry. The idea was not to say that, but the idea is just so that everyone gets benefited. I'm again taking the range. Click on the marks and take the entire range of data in your input range.
Okay, where is this window is popping up?
So you have to go to data analysis. Just click on data analysis.
Just can you show me the tool? It's a data, okay.
And under data analysis, you need to go to descriptive stats, sir.
All right.
Sorry. So I have taken the input range. Then because I have taken the label, I have to click the label in the first row and then the output range. So you can give any place, suppose this as an output range, any place on your screen where you would like to see the output. And because we are going ahead with descriptive stats, please click on summary statistics. That is what precisely we need. So under descriptive stats, we have not done much. We have only done 3 things. First, we have taken this input range. In input range, we have taken from marks till the last thing. We have take the label in the first row because we have taken the label. Then the output range is randomly selected any cell on the screen. And then you have to click on the summary stats and then you have to do OK. And if you see, this is the summary statistics that we have got. You must have got it on your screen. First thing we generally do is replace this marks word with summary stats. Now, if you see here, let's understand this first. The mean value of the entire data set. First, look at the last thing, count. That means the total number of students are 144. Out of 144 students, if we look at their marks, the mean marks are coming to be 7.389. And the median, that is the mid value, is 7. And the mode is 9. So if I look at the first condition of normality, my mean, median, and mode are not equal. But is the data still normal or no? That we'll be able to see with the help of skewness value. Now, if I look at the skewness value, this which is here, it is 0.30, which means it is less than 1, plus 1, or minus 1. It should range between -1 to +1. So it is ranging between -1 to +1. Because my skewness value is accepted as per the thumb rule, the data will be considered as normal. Now, this will be again validated with the help of the histogram that we'll be making. Are we able to get a bell-shaped curve kind of thing? That we'll be checking. Another thing is standard deviation is 2, sigma 2, the standard deviation that we saw there. Minimum value is 4 and maximum value is 12. And hence the range comes out to be 8. Why? Because maximum minus minimum is 8.
Ma'am, can you quickly go through that application of the tools once again, data tools, data analysis tools? What are the things that we had to select?
Sir, okay, I'll do it. Go to data analysis, sir.
Yeah, ma'am.
I've clicked it. Then click on the descriptive stats, sir.
Yeah.
And then click OK. I think we are together till now.
Data analysis, descriptive stats, okay.
So this,
the window has appeared.
Right, sir.
The input range.
Now, what we need to do is you need to take the input range.
Yeah.
Now,
I
sir,
can
the
select
input
all the
range
144 data.
Sorry, sir.
I can select all the 144 data in that column.
Yes, sir. The B column. That is marks.
Column, that is the marks. Yes.
You need to select the entire range.
Right. Then
you need to click, you need to check this label in first row because you have chosen label in the first row. Label means that anything which is written, just say marks is written here, that becomes a label.
So that should not be there.
No, that can be there, and you have to, if you have selected, which you have selected, you have to tick mark here.
Oh, no, I have not selected in this case.
Then do not tick mark here.
But
be selected.
Labels in first row, then it is unchecked.
Yeah.
In this case now.
Now you need to go to the output range, sir. Now for output range, any cell you can pick. Just randomly click on any cell where you would like to have this table.
Okay.
And then you need to click on the summary stats.
Summary statistics, okay.
And then you need to click OK.
Okay. Output range is the one that you, from the beginning, where you want to.
Output range is the place where you would like your table to be appearing, your output to be appearing.
Okay.
Like my output range was this, K2, K3. So I randomly selected K3 and my table is appearing here. So you just need to click on any cell where you would like to have your table, your data output. Output is this box, sir.
Okay.
It is not positively skewed because the value of skewness is positive.
Can you come again, please?
Ma'am, is the data not
No, the data
skewed
is
because the
not
value of
considered to be skewed because as per Carl Pearson, the value should fall between -1 and +1. It is falling between that. So the data will be considered to be normal, sir. Normality की ये definition है कि अगर आपका data -1 +1 के अंदर fall करता है, तो आप अपने data को normal consider कर सकते हैं. Although it is not a symmetrical data. Symmetrical data तब होता जब आपका mean, median, mode एक साथ होता, एक ही होता. 7 mean होता, 7 median होता, 7 ही mode होता. Then it would have been a perfectly symmetrical data.
की वैल्यू 3 होती, कर्टोसिस की वैल्यू भी 3.
कर्टोसिस की वैल्यू भी विद इन रेंज फॉल कर रही है सर. अभी हम लोग हिस्टोग्राम देखेंगे तो आपको और क्लियर हो जाएगा. I think we all are clear till now here. So the next thing that we are going to do is percentile. So for percentile, we need to first decide that how you are going to make your percentile. So generally, people go with 25%, 50%. Basically, this will tell us that what is the exact value below which 25% of data will fall. What is the exact value below which 50% of the data will fall? What is the exact value below which 75% of the data will fall? And if required, what is the value below which 99% of the data will fall? So these are percentiles that I'm calculating. These are, I'm writing here, guys. You please, aapko bhi ye likhna hai saath saath, please you have to type it on your screen because here we are going to compute it with a formula. So 25%, 50%, 75%, and 99% is what we are going to check. That how much data is lying below 25%, how much data is lying 50%, and here 50% should match your median because that is the value which is the median value. So let's calculate and check whether things are coming right or not. So I hope everyone has written this 25, 50, 75, and 90.
Yes, ma'am.
Now, this needs to be calculated. So we need to put a formula. So either you can simply go to this function here, and under this you have to write percentile. So the moment you will write percentile, you need to choose percentile as your function. So I have chosen percentile. Is equals to, when you write PER, percentile will automatically appear. Just select it, a formula will come. Are we together?
Yes, ma'am.
Yes, ma'am. Okay, so shall I go ahead? Now in this, they must be asking two things from you. One is array and second is the value of K. Now array is these marks. हम यहाँ पर लेबल नहीं लेंगे, will not be choosing marks word. हम लोग यहाँ पर B1 को नहीं select करेंगे. We'll simply select the values. So from 10 till the last of the data, all 144 values will be calculated as array. So I've selected my array. Comma, if you are doing it through formula, otherwise you must be having the input range also. Now, what is the K value? The K value is the percentage, the first percentage. I'm selecting K as 25. I'm just clicking the box where you have written 25. And I need to close my formula and I need to put an enter. I hope हम लोग सब साथ हैं.
Yes, ma'am.
And because we are blessed with the autofill function in Excel, we will simply go to this small green box you can see here and this plus sign, black plus sign, and you simply drag till 99. I've dragged it, you can see it. And just leave. The formula has already automatically calculated the values. If you see 50% is considered to be mean, which is coming 7 year, and that is what our median is. So median is matching. That means we have used the same, right formula.
Ma'am, in the autofill, the cell referencing has changed, so your array reference will change because we have not fixed the array.
In that case, you have to have a $sign, ma'am. I'll tell you how you need to do it. I'll redo it for you.
Excuse me, ma'am.
Yes.
Ma'am, can you repeat one more time from array?
Yes, I am repeating for those who are having any message from your Excel saying that your array is going to change. In Excel, we need to remember one thing, that whenever your array is going to change, you need to fix your array with a $sign before, after your column, number. So jahan par B likha hai, I'll give you an example here, like is equals to percentile, and then the now we are doing it again for all those who have not understood it for the first time. Percentile calculate karne ke liye, the first thing is we need to see that how I'm going to divide my data. So what I've done is 25, 50, 75, and 99. These are the percentiles that I have created. It's your choice. You can do it, but generally 25 is quartile 1, 50 is quartile 2, which is median, 75 is quartile 3. So Q1, Q2, and Q3 are these. If you want to calculate percentile, in the very next column, where you've put in the values, you first, put a is equals to sign. After is equals to, write percentile. The moment you will write TER, automatically there'll be a drop box and you have to choose percentile. I think we are done till now. Once percentile formula will come, then if you look at the formula, see, guys, just understand how Excel works. If you look at this formula, you can see that there are two things that this is asking, an array and a k value. Now, what is an array? Array is all these values, all the marks, except the label. And k value is the percentage I need to fix.
Anu ma'am, one participant is requesting you to please zoom the screen, or the font size can be increased.
Okay, just a second. I can try. Because I'm in the middle of the formula. Gaurav, and just tell me whether.
Yeah, ma'am, fine. It is fine.
Full screen.
All right.
Yes, thank you.
All right. So I hope you have written these percentiles. These are percentiles that I'm calculating. Now, in the very next box, you need to first put an is equals to. Let's do it together, everyone, please. Those who have not been able to do it in the first go. First put an is equals to, and then write PE. The moment you will write PER, there'll be a drop box like this. It may appear different in Windows, but there'll be a drop box for sure. Simply select the percentile thing. Now I think we are together. Now, if you see, they are asking for two things, array and k. K is the percentile that I would like. And array is the place where numbers are mentioned, where the marks is mentioned, where we have data. So first we need to first we need to select the data. So how do we select the data? We simply go here and we will drag down. We'll drag down till all the, data is selected. Okay. So I've selected the data. If I look at my formula, where is it? It has taken it. Now, in case your system is saying that your array is going to change, please put a $sign before B and after B. And then here also, before B and after B. I think I'm clear till now. Shall I go ahead?
Yes, ma'am.
Yes, now put a comma or other, if you have a box, then it must be asking the K value. Now in K value, you have to select this box where 25 is written. Just simply click this box. And then close your brackets and enter. There must be a value like 6 appearing in your box. Now go to 6, go to this autofill function and simply drag your autofill till the place where you have 99 written and click OK. And you must be getting some values.
Can you please tell why we put $sign?
This will fix up your array, sir. In some older versions of Microsoft, the array used to change. जब हम autofill करते हैं sir, तो autofill में वो automatically same वो लेता है हमारा marks के same column, same numbering को चलाता है. But कुछ पुराने versions में क्या करता है, वो बोलता है कि नहीं आपको fix करना पड़ेगा. तो $sign से fix कर देता है कि column fix हो गए हैं, column change नहीं हो रहे हैं. तो उससे आपका formula नहीं लेगा.
Okay.
ठीक है? So this is P25. This is P25.
Excuse me, I'm actually having a problem of data overlapping when I'm going for the data analysis and selecting that input range and output range and summary statistics. The table that is appearing, it is actually appearing on the existing data of descriptive, the initial data.
Okay, I'll help you. I'll help you. Don't worry, sir. Just give me 1 minute. I'll help you. So this is your percentile table. Okay. So now third thing is frequency. Before I go to frequency, let me just give me 2 minutes. Let me solve sir's problem. सर आप देखिए मेरे साथ साथ, आप पहले आप सिर्फ मुझे स्क्रीन पे काम करते हुए देखिएगा, तब आप रिपीट कीजिएगा. ठीक है सर?
Yeah.
Okay, now listen. I am simply clicking data analysis.
That's right.
I am selecting descriptive and I'm clicking OK.
Yeah.
Okay. Now what I'm going to do is I'm just removing everything here. I'm just unchecking everything so that we can go right. So this is something that must be appearing. Now I'll click on input range and I'll go and select my data. So this is my data. I have taken marks. You may not take. Simply you have to select the entire range of data. Okay, sir?
Yes.
So it has been selected. 145 tak it is coming. See, यहाँ पे 45 लिखा है या 145 आ रहा है ना? So that means it ठीक से आ गया. अभी क्योंकि मैंने label लिया था, I'm checking this label.
ठीक है.
आउटपुट रेंज के लिए मैं क्या करूंगी सर, कहीं पे जहां भी मुझे आउटपुट चाहिए, मेरा डेटा तो यहाँ है, मैंने ये वाला कॉलम सिलेक्ट कर लिया H44.
Alright, वहां पे अपीयर होगा वो. अच्छा.
तो यहाँ पर मैं पहले यहाँ क्लिक करूंगी, पहले आउटपुट रेंज पे यहाँ, और फिर मैं यहाँ पे क्लिक करूंगी.
ठीक है. ओके.
और फिर मैं समरी स्टैट्स को क्लिक करूंगी. और फिर मैं ओके कर दूंगी. तो मेरा डेटा क्योंकि मेरा ऑलरेडी है तो इसलिए दोबारा नहीं आ रहा, बट आपका आ जाएगा सर.
Okay, thank you.
Okay, sir. Till now,
Ma'am, I have a doubt.
Yeah, please.
Ma'am, I am getting answer as 600%. So why percentage is coming in the output? Instead of 6, 7, 9, 12, my output is coming as 600%, 700%, 900%, and 1200%.
So you do it again. You please just try. मैं बोलती हूँ आप वो कीजिए. वही फॉर्मूला है सर. Is equals to
format.
The cell format is different. You need to change the cell format.
Cell format को number में कर लीजिए. Change into the number. Cell format. Cell format is in percentage.
Okay. Thank you so much.
Okay. So now the third thing that we are going to do is the frequency table. Just give me 1 second.
Ma'am, though I have done it, but there was one problem when I was putting the formula percentile, वो drop down में आ गया, लेकिन जब मैं उसको select कर रही थी तो वो हो नहीं रहा था, मुझे पूरा type करना पड़ा formula. ऐसा क्यों?
मैम ये तो आपके एक्सेल की प्रॉब्लम है मैम.
अच्छा, मतलब अपडेटेड वर्जन का कुछ इशू है इसमें?
मे बी हो सकता है मैम कि अपडेटेड का हो इशू. तो मे बी
अदरवाइज वो क्लिक करके अपने आप हो जाना चाहिए था
जनरली ड्रॉप डाउन. हाँ, जनरली हो
Click
जाता
it 2 times. Click it 2 times. It will happen.
Okay, okay. Maybe. I'll try.
हो सकता है, आप ऑप्शन पे हैंड होल्ड से इनेबल कर देंगे तो हो जाएगा.
Okay, now we are going with the third thing, which is the frequency table. I'll show you here and then we'll be making it there. Now listen, this data is, if you see, because it's your data, if you generally see, the data is roughly falling between 0 and 12. So as a researcher, we need to just have an idea of the ranges that the data is falling, which we can also find from the, the descriptor stats, which is the minimum value is 4 and the maximum value is 12. If you see here, this will give us fair idea कि हमारा data की minimum maximum value क्या है. As a researcher, आपको class, सबसे पहले आपको class generate करना पड़ेगा. Class generate करने के लिए क्या होगा कि जैसे अब मैंने यहाँ पर किया, which you will be doing on that sheet and I'll be doing it with you there. But you just need to understand here. What I've done is I divided into class because my minimum value is 0. I've made first class as 0 to 4. Second class 4 to 6, 6 to 8, 8 to 10, 10 to 12 and above 12. ये कोई hard and fast rule नहीं है कि you'll be making the same classes. You can make your classes as per your own data, as per your own frequencies. And this is just an example here. The first thing when we are, and when we are trying to draw a frequency table and a histogram, the first thing that we need to do it, we need to make our own classes. This we will be doing. So I have made these classes. Once I have made the class, then we need to mention what is the lower bin and what is the upper bin. Now, lower bin is the lower value here, and the upper bin is the upper value here. Like for an example, in this case, if you say that the first class is 0 to 4, the minimum value is 0 and the maximum value is 4. So lower bin value is 0 and the upper bin value is 4. Similarly, if you see the next class, 4 to 6, the lower bin value is 4 and the upper bin value is 6. And likewise. So first thing is we'll be doing this. So let's go to our sheet together and let us have our lower bins and upper bins. So first we are making the class. That is the class that I'm making. The second column we are writing lower bin. And please do it with me because इसी से हमारा frequency और histogram बनेगा. So we have to do it together. So class, lower bin and upper bin. So you have to first add these three things. Now, in class, I have taken 0 to 4, 4 to 6, 6 to 8, 8 to 10, 10 to 12, and above 12 in case any, we just write above 12. So please make this on your sheets, and once you are done, please let me know. Then you have to do the upper bin and lower bin.
Ma'am, I have completed, but what to write in 12 above this row?
Nothing, you just write above 12. Because
नहीं, lower and upper bin.
अभी मैं बता रही हूँ. इतना हो गया सर? अब लोअर बिन में लोअर वैल्यू 0 और 4 में लोअर वैल्यू कौन सी है? 0.
Yes, ma'am.
4 to 6 में 4, 6 to 8 में 6, similarly 8, then 12, sorry, then 10, and then 12 because it's above 12. I hope lower bin is sorted. Then the upper bin. Upper bin is the upper value. So 4, here it will be 6, then 8, then 10, similarly 12, and we are leaving this because we don't know how much
Ma'am, we
upper
have to
values
do
we
this
do.
manually. If you have a larger data set, then also we have to do it just manually, so, ma'am.
This you have to do manually. Yes, ma'am. There is no shortcut.
And this lower bin and upper bin is regarding the lower class and the upper class, but not whether the lowest value in that particular range in our actual data set, that is not we are taking. We're just taking the lower class and the upper class value, right?
Yes. What we have done is, based on the minimum value and maximum value that we could see from our descriptive stats, we have fair idea that my values are falling between 4 to 12, if you can see here. And since there are 144 values falling between these two, so I can make my own classes. So what I've done is I simply made the class because 4 से नीचे कोई है नहीं, but I would not like to start from 4, तो मैंने 0 to 4 को first बना दिया, 4 to 6 को second, similarly 6 to 8, 8 to 10, 10 to 12 and above 12. 12 के ऊपर भी देखिए कुछ नहीं है, highest value जब 12 है तो उसके बाद तो कुछ है ही नहीं. So मैंने क्लासेस हमने अकॉर्डिंगली बना ली, 2-2 की बना ली, 3-3 की भी बना सकते थे आप यहाँ पर. ये आपकी चॉइस है मैम, आप इसको कैसे बनाना चाहते हो, ठीक है? दिस इज प्योरली अप टू यू.
Okay.
And then lower bin and upper bin basically means which is the lower threshold value that you have taken to start a class, and the upper threshold value that will decide कि इसके आगे वाला next class में जाएगा. So basically 0, 4, 4, 6, 6, 8, 8, 10, 12. Because यहाँ हमने above 12 लिखा है तो पता नहीं वैल्यू कहाँ तक जाएंगी, तो हमने इसको blank छोड़ दिया. So this is the logic. So I think this all is done. Now we are making histogram and frequency class. So how we are going to do it? We are going to data analysis. Everyone please click data analysis. Go to histogram. Histogram is what you need to choose here. And you need to click OK. Okay? So there's a table that must be appearing here. I'll just remove everything from here. Okay, so this kind of table must be appearing. Now, first thing is input range. As we know, what is the input range? The data set. Because यहाँ पर label का option है, आप label ले सकते हो, तो मैं label ले रही हूँ. So I'm starting with B1 and I'm dragging it to B145 because there are 144 values. And see here in my version of Excel, the dollar is automatically taken. In case आपके में डॉलर नहीं आता और आप एरे पे काम करते हो ऑटो फिल के लिए, तो आपको फिर डॉलर्स लगाने पड़ते हैं, बट अभी आपको जरूरत नहीं है. Okay. So we have taken the input range. I hope we all are together. Shall I go ahead?
Yes, please.
Now, in the bin range, we will be only selecting the upper bin. In bin range, we'll only be selecting the upper bin. Only the upper bin. Because Excel only takes upper bin value and automatically calculates the lower bin value. If we'll tell them the upper bin value, it will automatically understand that this is the range that the person has made. So we have to only select the upper bin value. Now I am checking the label because I've taken the label. Those who have not taken the label, you can please uncheck it, deselect it. वैसे automatically select नहीं होता है, so do not check it.
Ma'am, why you have not taken above 12?
because if you go to your descriptive stats table, just look at the minimum and maximum value you are getting in my data. क्या आ रहा है मैम maximum
So do you
value?
mean that these are outliers above 12?
No. आप पहले मेरी values को देखिए मैम.
Okay.
आप minimum और maximum value देखिए कितनी आ रही है. जो आपने descriptive का table बनाया है ना मैम, उसमें आप minimum value देखिए 4 है और maximum value मैम 12 है. 12 outlier है या नहीं है अभी नहीं पता, वो histogram से पता चलेगा मैम. ठीक है?
Okay, so we have to restrict ourselves to the maximum value.
Obviously मैम, because हम frequency बना रहे हैं तो डेटा उसी में फॉल करेगा ना मैम. फिर भी हमने अबाउट 12 का एक डाल दिया जिसमें कोई वैल्यू आएगी नहीं, बट डाल दिया अबाउट 12, इसलिए हमने उसके अपर बिन को लिमिट नहीं किया.
अच्छा,
ठीक है. ओके, नाउ आउटपुट रेंज क्लिक करो और कहीं पे भी सिलेक्ट कर लो. मैंने ये सिलेक्ट कर लिया आउटपुट रेंज. और चार्ट आउटपुट को जरूर सिलेक्ट करना, इससे हिस्टोग्राम भी साथ में आ जाएगा. परेटो हिस्टोग्राम इज inverted histogram. We are not going to do that. We are simply looking at the normal histogram. So just click on the chart output. So I think ये सारी values सबने डाल दी. Input range is the marks. Bin range सिर्फ upper bin values लिए हमने. Label को select करना है in case you have taken the label while choosing your input range. Output range, randomly select any box where you feel there's a place where your data can come. Then you need to go for chart output, because we need to see the histogram also. And once all is done, please click OK. Okay. Now, where is my frequency table? Just 1 minute.
And we have got the frequency table.
I have not got it. That's what I'm looking at. Why I have not got it? You have got the frequency table?
Yes, ma'am.
That must be there. There is some problem. But आपको ऐसा एक frequency table मिला होगा, कुछ ऐसा.
Yes, ma'am.
इसका मतलब क्या है कि आपकी जो values हैं between 0 and 4 is 16. 0 and 6 is 36, 0 and 8 is 48, 0 and 10 is 31, 0 and 12 is 13. And more जो हमने 12 above लिखा था, आप देखिए यहाँ पर 0 आया क्योंकि कोई value 12 above है ही नहीं. और जो आपका हिस्टोग्राम आया होगा वो कुछ इस तरीके से आया होगा. अगर आप इसको देखिए तो ये more or less एक बेल शेप कर्व बना रहा है. देखिए there is no outlier. कहीं पे यहाँ पे आगे जाके कोई outlier प्लॉट नहीं है क्योंकि 12 के बाद कोई है ही नहीं. जब 10 से 12 के बीच में ही आपका जो 13 वैल्यूज हैं और 12 के बाद कोई वैल्यू नहीं है तो मैम there is no outlier. आपको यहाँ से समझ में आएगा कि कोई आउटलायर नहीं है आपकी वैल्यू में.
Yes मैम.
मैम हिस्टोग्राम में बार्स कंबाइंड होनी चाहिए, गैप्स क्यों आ रहे हैं?
मैम ये बहुत टाइप के हिस्टोग्राम्स होते हैं, आप इसमें अपने अकॉर्डिंगली चूज कर सकते हैं. एक सेकेंड.
वैसे दिस लुक्स लाइक ए बार डायग्राम, नॉट हिस्टोग्राम.
मैम इसमें आप ना चेन चार्ट टाइप में
टिपिकल में आई थिंक इफ यू गो.
Excuse me, ma'am. Ma'am, I'm having trouble to offset input output reference.
एक मिनट मैम, पहले मैं जरा मैम वो ग्राफ का वो चेंज कर दें, देन वी कम टू दैट.
It's okay, ma'am.
No, but then we can change the chart type, ma'am.
But this is not a histogram.
Yes, ma'am. We can reduce the sizes here.
Yes, this is a histogram.
I know, ma'am. This is what Excel calculates for us, ma'am. फिर हमें ना यहाँ जाके इसको change करना पड़ता है, ma'am. This is what automatically Excel do for us. So फिर हम लोग इसको accordingly अपने shape change कर लेते हैं. आप क्या कह रहे थे, ma'am?
Ma'am, I'm getting the message having trouble to offset input output reference.
मैम आपने कहीं कुछ गड़बड़ किया होगा, लोअर बिन अपर बिन रेंज या डेटा में आपने कुछ गलत एंट्री वेंट्री, आप एक बार दोबारा करके देखिए, बिकॉज जनरली ये आ नहीं रहा है।
Ma'am, can I ask?
Please.
Ma'am, we have also other softwares like SPSS where they check normality and all that. So if we can do, what is the difference? I mean, between Excel and SPSS over there also.
SPS is just the paid version and not available with everyone. Though there people have.
I mean, what we can do for SPSS, we can do also in Excel. The same thing we can do.
Yeah,
also.
ma'am. Those who do not have access to SPSS can go ahead with Excel. And but that is why
for any chance, by any chance, if my data is not normal, like over here, it is very nicely showing it is normal, but if it is not normal, then how do we operate with that Excel? In Excel,
there are different ways of dealing with outliers. If your number of observations are really, really large, then they generally say that if your number of observations are large, and if the data that you are taking from, the population or the sample is something that can be removed, then we particularly remove those couple of, observations to make it fine. But agar hame lagta hai
if I remove outliers, then will my non-parametric data set become parametric?
मैम वो चेक जैसे मैं बताती हूँ आपको, जब हम लोग SPSS में करते हैं and we go to SEM या हम कुछ और करते हैं, तो इसमें there are some methods in which we can deal with outliers. हमें समझ में आ जाता है कि कौन से पर्टिकुलर ऑब्जर्वेशन है जो हमारे डेटा को स्क्यूनेस बढ़ा रही है जिसकी. So there are methods of dealing with outliers. But अगर आपके outliers बहुत ज्यादा है, नॉर्मेलिटी में देखिए थोड़ा बहुत इशू, जैसे when I did my PhD, मेरे पास डेटा था around 1200 people and there were 4, 5, 6 outliers. Then I was told to remove those outliers. But if your data set is something where outliers are, एक तो आपका number of data is very less and then उसमें आपके outliers जो हैं वो कुछ ज्यादा ही हैं, आपके 15-20 values हैं जो outliers हैं और आपका डेटा से 100 का है, then आपको फिर outliers नहीं हटा के फिर आप normality वाले कोई भी टेस्ट, आपको नॉन पैरामीट्रिक टेस्ट करने पड़ेंगे और आप कोई भी वो डेटा एनालिसिस नहीं कर पाओगे जो नॉर्मल डिस्ट्रीब्यूशन पे होता है. देन यू गो फॉर
नॉन पैरामीट्रिक टेस्ट इस एक्सेल में होगा, but is it possible to do in Excel नॉन पैरामीट्रिक टेस्ट?
हाँ, आप वो निकाल सकते हो ना, chi square इज अ नॉन पैरामीट्रिक टेस्ट. तो कुछ एक दो जो है वो यहाँ निकल सकते हैं, बाकी आपको एक्सेल में करना, बाकी आपको SPSS में करना पड़ेगा. या आई थिंक हिमानी मैम इज एक्सपर्ट विद आर, आई थिंक आर से भी हम निकाल पाएंगे नॉन पैरामीट्रिक टेस्ट.
ओके मैम.
सो हिमानी मैम.
Ma'am, she's joining in a few minutes.
Excuse me, ma'am. Excuse me, ma'am. Excuse me, ma'am.
Yes, ma'am. Yes, ma'am. Please tell me.
Ma'am, like as we came to know about normality of the data with the histogram, so and if we talk about descriptive summary, then like our mean median mode is not equal, and then we see the skewness and kurtosis. So like our kurtosis value is 3. If we compare the kurtosis value that is equal to 3, less than 3 and greater than 3, so we take benchmark as in 3, and in skewness we take benchmark as in 0. So what range we can set for to check the normality if we check without histogram? Like from histogram we came to know it is normal.
Good, ma'am. देखो, the skewness and kurtosis value are basically used to check the normality conditions. Now different statistics and different methods that we are using talks about different things. मैं आपको example दे रही थी, when we use SEM, they say ±3 की range में if things are falling they are normal, but because the data size is really large. But when I am talking about Carl Pearson, minus and +1 के बीच में if your skewness value is falling, then your data is normal. So whatever, so there are some thumb rules within which जब हमारी value fall करती है तो हम कहते हैं कि our data is near to normal. It is.
Well, it depends on the
skewness and kurtosis value, and the kind of statistics you're applying for your inferential stats.
Okay, fine, ma'am. Fine. Thank you, ma'am.
Most welcome, ma'am. So thank you so much. I hope you are enjoying the FDP, the R thing. We'll just get back to you. Just 1 minute. Thank you so much. Himani, ma'am, you're there?
Yeah.
Thank you, ma'am. Thank you, Dr. Anu, ma'am.
Thank you so much, ma'am. Thank you so much. Pleasure is all mine. Thanks. Over to you, Himani, ma'am.
Yeah. So guys, if we don't have a break,
Dr. Himani,
will it work for you?
Yes, ma'am. Sure, ma'am.
So
yes,
we can,
ma'am. Sure, ma'am.
because if we are going to take a break, our session will be extended and it will be lengthy one then.
Dr. Himani, I have a question before you start.
Yes, ma'am.
When you did that log differencing,
Yeah.
we plot ACF and PACF after that.
Yeah.
Even those vertical lines are not within that confidence interval.
Yeah, I'll show, ma'am.
So you do it twice?
Yeah.
You will show it?
Yeah, I'm going to show it, ma'am.
Thank you.
Now we are here again. Now in the previous time, we have just plot this, and now if we are going to calculate ACF, now ACF of, let's say, N225. So is our N225. Now see, ma'am, if I'm taking the ACF right now all the spikes are within this thing. Now you will see the spike of 7. That means 7th time period is somewhere over here, or the 2nd time period is touching it. But if we will move to the previous spikes, now let's say over here, let's say C, this was ACF for the previous life. All the spikes was crossing this upper limit. Now if I'm moving towards, if now I'm taking the spikes, you will see that all the spikes are within the limit. Only
what was the first one?
Which one, ma'am?
Zero lag, at 0.0.
This is current situation. So we have to see whether this is, no, it doesn't matter. It will always be above that. Your current, we have to see whether this situation is correlated with the previous one or not. So now you will say it's not correlating. But yes, over here in the second lag, you can say it's near about touching the upper limit. So it can be correlated with the second lag. After second lag, it is correlated with around 7th lag. And after that, you will see that it's correlating around 24th lag. Now, when we will be doing the ARIMA model, then you will be learning how to find that which lag is suitable for your model.
Okay. Because in PACF, I think a lot of lines are outside.
And now let's calculate PACF also. If I'm going to calculate PACF of same thing, RN225. Now see, you will see the 7th line is 7th line, or over here 24th line, the same line that ACF is showing. See, ACF is also showing the 7th line. ACF is showing 7th line is crossing the lower limit. And over here, you will see 24th line is crossing the lower limit. And same is with the PACF. In PACF, you will see that 7th lag is crossing it and 24th lag. And all other spikes are within the limits.
So, ma'am, 7th and 24th values are affecting our present value more.
Yes. These two are affecting our present value more. So now, as per the model, we have to select whether we will take lag 7 or we will take lag 24. But we never go for lag 24 because the time period gap is more. So maybe our model can say it will be lag 7, or somewhere you will see lag 2 also. It's near about the line. So sometimes model also take this value also. So that means your current value will be depending on the previous, you can say T minus 2, previous to previous value. So whenever we will be constructing the model will tell us that which lag we have to take. And we can validate our model also. We can check the robustness whether the model which we have created is correct or not. So
Madam,
can we,
hello.
yes, sir.
Madam, at the part of interpretation, when we are interpreting the stationarity aspect or trend aspect,
yes,
then how we interpret ACF with respect to PACF? How we use these two
So
information?
yes, because whenever we will be doing ARIMA model, in ARIMA model we will be talking about AR term and MA term. So ACF is related to AR term and AR term is related to your PACF and MA term is related to ACF. So whenever we will be interpreting that part, so we will be mentioning that, we will be giving up the backup with the literature. And we will be showing these diagrams over there. You have to mention these diagrams in your literature. So you just copy paste over there and you can paste it over there. And the proof, we will be using the test with the help of the various tests. We will be proving the normality test. We will be proving the stationarity test. So all the proofs will be there with the help of our various kinds of tests which are being constructed by various economists. So till here it's clear how to construct ACF and PACF.
Do we have to keep saving these diagrams in order to?
Ma'am, unless and until you will close this R, it will be there. Now, once you close your R and laptop, these all the diagrams will be vanished. So till here, see, I have not closed it. So whatever diagrams I have made, I'll get all the diagrams.
No, I'm asking from point of putting it in a paper.
Yes, you have to save it and put it on your or okay, you can just open a Word file and just paste it over here so that you can use it in the future.
Ma'am, just one thing to conclude. So PACF is the one that is determining the number of lags, not ACF.
Ma'am, both are determining. One is determining for exogenous variable, you can read residual, and one will be doing it for your actual data. So that we are going to learn in ARIMA model. When we are going to learn ARIMA, we will be learning in that.
Okay.
But before that, now without wasting that time, let's move to the next topic, that is structure change. Now, what do you mean by structural change? In yesterday's class also, I just talked about structural change. Now, let's talk about this diagram. Now, if you will see this diagram, there are various structural change. For example, let's say I say that COVID is there right now, COVID is there. So as the COVID entered, the stock market shuffled. There is a change in a stock market. Or you can say in 2007 and 8, there was a financial crisis. So at that time also, the stock market changes. So there is a change at that particular time. So the first thing is, whenever you are forecasting any data, you have to see whether there is a structural change in your data or not. For example, let's say just import one file. Reliance sale. Just import this file, Reliance sale. Have you imported the file Reliance sale?
Yes, ma'am.
Now, and you have also attached the file. You have also attached the file?
Yes, ma'am.
Okay, now let's check whether in this data there is some change or not. So just make a graph, plot.ts, and your variable name. Over here, I have taken only one variable, so it's Reliance sale. Reliance underscore sale is your variable and Reliance sale is your file name. So we have to attach file name, and whenever we are plotting, we have to select the variable name. So just select Reliance underscore sale and then plot the graph. Done?
Yes, ma'am.
Now you are seeing the graph like this. Now see, from here, when the sales start, I have taken the year from 2001. See, my data is still from 2001 till 2021. So 21 years data is there, but from 2001, if you are seeing your value, just go to the first window and see the value is 69,000 something, then 71, 76, 78, 81. That means there is a trend, values are moving up, but what happens suddenly in around 2013, 2012 or 13, or even after 2014, just see the trend in 2014. From the trend was that the value was increasing by 2,000, 3,000, 4,000, but suddenly after 2013, value jumped to 1,54,318. So that means there is a change at this period, because I have taken the data of year wise, so we can predict it over here, we can calculate it. But if I take the daily stock market data from 2000 till 2021, so I think you are going to get around 8,000 data. So in that, it will be very difficult to calculate whether there is a structure change or not, whether there is a change in the data or not. Now over here, I am clearly seeing that there is a change in the data. There is a jump over here. And if I'm not able to calculate from this table, I can just see it from the graph. See, there is a change. And now you will see it's around 2013. If you will plot by GG plot, you will get the year over here and you will see it comes around 2013. 2013, near about 2013, the change is there. After 2013, the change is there. Now, do you find any other change? Is there a change after only 2013, or after that also something happens so that the change is there? Even if you will see the stock market in 2020, when the COVID was there, so you will see that there is a drop in the stock market, and again stock market gained the index. So there is a change. So we have to find out whether there is a change in our data or not. Because if I'm going to predict this complete data, this data, my result won't be correct, because my prediction will be a straight line. I'll be creating a linear model, a regression model that will be a straight line. Because right now we are learning about the linear model. We are not learning non-linear model. So my prediction will be wrong.
Won't the error term take care of any change, even if you're doing
No. Error term won't change, won't take care of. We have to see whether there is a change in our data or not. So there are different, you can say, packages which will show us whether there is a change or not. So this change we are able to see with the help of diagram. Now let's see with the help of the softwares, what the software is showing to us. The data is showing that after 2013, there is a change. And your diagram is also showing that after 2013, there is a change. Now let's do it with the help of softwares. So for the software, just install struct package. A struct change. So the package name is struct change, and just install it. Done?
Yes, ma'am.
Okay, let's library it. Library struct change. Done? So first of all, let me write the steps over here. So the step 1 is install package struct change. Once you have installed it, your step 2 is library. In the library, you have to install the package struct change. Once you have done with this, now let's move to step 3. Now, even you can write step 3 plot.ts. So you can check it from plot.ts that we have already done. So plot.tf and your variable name. So in that you can check it and now validate it with the help of your. So till here everyone is with me. Now can I start with the validation?
Yes, ma'am.
Now, okay. So step 4. Now in step 4, what we are going to do, we are going to create a model. Now model will show us whether there is a change in our data or not. There is a structural change in our data or not. So for that, just write F. Let me write it over here. F stats. Now once you write F stats, you will get it in the drop down menu. Just click on that. F stats. Wait a minute, I have to give some name. So let's say I'll give the name as ZX. So I'm creating the model. Whenever you are creating some model, you have to give some name to that model. So you can give any name. So I have given ZX, F stats. Done till here. Now after that, you have to write the name Reliance, variable name Reliance underscore sale, and again till 1. Done till here. From equals to 0.01. Now everyone has done till here.
Ma'am, after library,
Yes.
we need to directly go for this ZX.
Yes, yes. You can write ZX, you can write X, Y, you can write
Plot TS, we don't have to do it, no?
No.
Here in console.
A plot TS is just to show whether in the diagram there is a structure change or not.
Then why we have started from 0.01?
Yes, from 0.01 because I want to see from the starting, from the first value till the last value.
Each and every time we need to start it from 0.01
yes,
only?
Yes, ma'am. Because this is a software, it will automatically give you where is a structure change in your diagram or in your data.
मैम वो जैसे आपने रिलायंस सेल के बाद ये सिंबल लिया है तो ये सिंबल अपने आप से आता है या
नहीं मैम, हमें लगाना पड़ता है। ये आप टिल्ट का सिंबल मैम आप देखोगे टैब के ऊपर आता है।
हाँ जी, अच्छा ठीक है, हाँ जी ठीक है मैम, थैंक यू।
And one, why I have taken 1? Because my one variable is there. I am considering only Reliance sale is one variable because we are working on univariate analysis. Now, once you have done it, press enter. Now, once you press enter, you will see that ZX figure is there. In environment, ZX is there. Now, after that, just write SC structural change test. SC test. Yes.
Ma'am, I'm getting an error in fstats, could not find function fstats.
You are not finding it because I think you have not installed the struct change then.
Okay.
Just install it.
No, I did. I have already installed it.
Have you put it in the library?
It's showing package struct change successfully unpacked.
Ma'am, once you put in the library, if in the drop down menu struct change is coming, that means your package is installed. If it's not coming, that means your package is not installed.
I'll just check now.
Now, everyone has done this SC test, and in the bracket you have to write the name of the series or model that you have created. I have given the name ZX, so I have put ZX. Now, all of you are getting this value?
Yes.
Yes, ma'am.
Now see. Now we have to see whether our data has a structural change or not. So we are we are creating the hypothesis. So let's say my first null hypothesis is, what will be our null hypothesis?
No structural break.
There is no structural break. So our alternative hypothesis will be there is a structural break. Now, if you will see the p-value is coming less than 0.05. So which means that my null hypothesis is not accepted. So if my null hypothesis is not accepted, it means there is a structural change in my data. Till here, are you getting it? That now we have proved that there is a structural change in my data, and you have to show this data in your research paper. You have to prove it that there is a structural change. Now, if it is the value is more than 0.05, so which shows that we accept our null hypothesis and there is no structural break, and you can directly move with your analysis part. Now, since this is showing that there is a structural change, now let's see where is my structural change. Now for that, our step 5 will be to check the points where there is the break. So let's see the break. In the diagram, we are seeing that break is around 2013, and that break is also validated with your numbers. Now let's see what the software is saying. Now just write struct change. Struct change, you will get in the drop down menu. After that, write breakpoints. We have to see where is the breakpoints. Now breakpoints, and just write the file name or your variable name. Reliance_sale till to 1. Done.
Yes, 13 and 16.
13 and 16. That means now over here, 13th value. And if I'm going to Reliance sale, now you will see 13th value is 2013. And over here also is showing 2013. And next value, next break is till 2000 at 2016, because 16th value is 2016. Now, if you will see the diagram, you will see some around 2016 also there is a change. It's a little bit bend over there, and there is a change around 2016 also. So that means now there are 2 breaks in my data, one at 2013, one at 2016. Now, as a researcher, I have to take a call whether I have to study 2013 to 16, I have to study 16 onwards, or I have to study from 2001 to 2016. So now you have to see where you have to study, or even you will find some research papers where the comparison is done. If we are taking overall data, this is my result. If we are taking the break, that means first break is from 2001 till 2013. Second break is from, second data we can take from 2014 and 16. And after that, we can break it from 16 onwards. So that means we can individually done for 3 periods and 1 for overall, and then we can compare it. Or even you can take after 16. So you can predict the values after 16, because before 16 there is a break.
So we can take the data only when there is no structural break. We can take.
If there is no structural break, you can take the entire data.
Okay.
Now, if we are seeing that there is a structural break, so we can find the break, at what point the break is there, and we can move it forward. Now over here, and now as a researcher, it's my call whether I want to take 2 breaks or if I want to take 1 break, because this 16 break is somehow merging with that only. If you are seeing 2013 break, it's clearly visible, but this 2016 break is not clearly visible. So software is showing that there is a break at 16 also, but as a researcher, you have to take a call whether you will take 16 onwards as your data, or you will take 13 onwards as your data. Or even you can do from 16 to 13 to 16 and then 16 onwards, and you can compare it. What is the difference between 2 time periods? Till here, any doubt?
If we want to take all the data
Yes.
and want to make it data stationary,
Yes.
can we go ahead like this case, na?
Yeah, it's as a research, it's your call. You can do it.
But then will the results be meaningful if there are structural breaks and we are
No,
taking
ma'am.
the entire
No,
data?
no.
So then
Forecasting won't be meaningful. So that's why I'm saying you can compare it and you can show it in the research paper that we have taken 3 periods and why we have taken 3 periods, how we choose these 3 periods, that is due to the structural break.
Okay.
So for example, over here I have taken in 2013. So you can see from the literature what has happened in 2013, why this break is there. So you have to mention in your research paper why the break is there, why we have taken this period, because we cannot choose any period randomly. I cannot take that first period, I'm taking 2001 to 2005, then I'm taking 5 to 10, then 10 to 15. I have to show it why there is a break, why this period is being selected. So there something must have happened. Now, if you talk about share market, if you will work on share market, let's say, okay, I'll just give you a small part, Argentina. Now, in 2008 or 9, there is a demonetization in Argentina, or you can say there was some crisis in Argentina. If you will look at the Google, or if you will take any US company data or US index data, in 2007, there is a crisis, financial crisis was there. So whenever you are going for a structural break in that data, you will find the structural break in 2007. So we have a validate reason that in 2007 financial crisis was there and our software is also showing us the same. So we are validating our proof that this period, the period that we have selected is a correct period. Till here, any doubt? Can we move further?
Ma'am, it has nothing to do with lag selection. Isn't
No,
it?
no. It has nothing to do with lag selection. Now, first thing is we are just finding that whether there is a break or not. Now, yes. Now,
All with the stationarity.
no, it doesn't have to work any stationarity with that, because we are just finding that whether there is a structural break, what period should I select. For just for selecting the period, I have taken the structural break. Sometimes researchers want to compare 2 time period. For that, you should be aware that what is the structural break.
It is just a justification for the period range we are taking.
Yes. Now you have already learned about descriptive statistics. Now let's see the descriptive statistics, how we are going to get it in R. So I will not be going in the details, what is mean, median, mode, skewness, kurtosis. I'll be just showing you how we are going to get it. Now just write summary, and you all have share price file. So just write share price. Are you getting this?
Yes.
So over here you can say, because I have written share price, I have written the file name. Since I have written the file name, so in the file, if I go to the share price file, the first column is for date, second for N225, then BVSP, and then SSCI. So this is a software, it will not understand. So it will show you the minimum, maximum, all the variables, even the date will be shown. So we don't have to consider date. You have to just see your N225, BVSP, SSCI. So minimum value is this: first quartile, median, mean, third quartile, and maximum. But skewness kurtosis is not there. Now what to do?
Ma'am, can I interrupt a little bit over here?
Yeah.
Ma'am, over here, they're nicely showing it over here. How do I take it to the Word document from here?
Ma'am, just copy paste.
Oh, just copy paste will do.
Yes.
Okay, then that's good.
Okay. Now over here you are seeing the skewness and kurtosis are not there. Now if you want to have skewness and kurtosis, just install one package more, that is F basic. Have you installed F basic? And second package will be T series, time series data. So just install these two packages, T series, that is named as time series, and next package is F basic, basic statistics. So just install it and put it in the library. Library, T series, and library, F basic. Done?
Once it is there in the library, again and again, we don't want to. We have to.
You have to do only once. After opening the R, you have to put the data, put your package in the library only once.
But data, we have to do it attach once again and again.
Have, no. Once you are opening R, for example, right now my R is open right from the morning. So I have not attached the file again and again. Once I have attached, it will be there.
From the morning, once I open, that is okay. Even yesterday, if I work with that data, that will again have to attach it today.
Yes.
Like opening the book.
Yes, opening
but
the
library, once it is installed, it is always there.
Yeah, it will always be there, but you have to put it in the library, because in the library, the this F basic, once I close the R, it will again go to the shelf. I have to recall it that I have to work on it.
Oh, then both are, before I start the work, both I have to do.
Yes. Okay. Once you have to put it in the library, and second you have to attach it.
Okay.
Now can we move further? Till here it's clear?
Ma'am, can I ask a question, please?
Yes.
Ma'am, in the data, what is the minimum number of entries that you need to have to do this analysis? So it's a very basic question that I'm asking.
Ma'am, minimum number is whatever you want to, but it should not be one only.
So, I mean, less 30 is a good number?
No, ma'am. No, for the time series analysis, no, 30. As more and more data will be there, your result will be validated with that.
So it should be at least more than 100.
More than 100. Yes.
Okay, sure. Thank you.
And if you are taking more than 100, that means either you have to take monthly data, you have to take yearly data, but you have to increase your data. Okay, now let's see the commands that we are going to use. Now just type basic stats. Once you have written basic stats, just write the name of the variable for which you need the basic stats. So first of all, I'm taking for Japan, whose variable is N225, and just click enter. So now you will see, you will get everything over here: mean, median, sum, your upper limit, lower limit, variance, standard deviation, skewness, kurtosis, everything is there.
Ma'am, for skewness and kurtosis, are we taking the reference value of 0 here, or are we taking the reference value of 3 as the textbook formulas?
3 will be there, but it's showing just a value. Now see, over here, it's showing is exponential value, sir.
Yeah, no, that I got. What the package is using as a reference value?
Because will use Excel... 3 only. No, it will use, it's standardized. It will use
in Excel, they use 0, if I'm not wrong.
No, we have to predict whether it's coming for more than 3 or not. That we have to validate in our results.
Okay.
Now, suppose, now this thing is clear. Any doubt over here?
Ma'am, what is the meaning of E?
E is exponential value.
Okay.
Now that means over here, I can say that E means if I have to convert it into 0, so our answer will be, it will be 4 point something, whatever it's given. Multiply by, no, it's 1 divided by. It's 1 divided by 4 raised to power 1. So our answer, it will be around 0.04, I think so. You have to convert it, it will be 0.04.
Ma'am, after library T series, I am getting a message. There is no package called T series.
Ma'am, you have to install it first. Go to
T series
tools.
also.
Yes, you have to go to tools, install package, and just write T series over here.
Okay.
And then install it. But installation is only once. Now, whenever you are going to open it, you don't have to reinstall it, because if in a college library we have to purchase books, we are purchasing books only once and then put it in the shelf. And whenever we have to read it, we have to take out that book only. We don't have to purchase the book again and again. Similarly, we have to install the package only once, and it will remain in your R, and every time you open R, you have to just library it. You have to just open that book, your package, and you have to start working on that package.
So, ma'am, every time we are installing a package,
no,
new package,
no,
we have to library it.
Yes, whenever you are installing a new package, you have to library if you have to work on it.
Okay, ma'am. So
for
next
example,
time
right now,
yes,
for example, over here, if I'm making the plot, I'm not showing the years over here.
Yes,
so I will not library ggplot2. Now, if I want to show the diagram, that year should also be mentioned. So first of all, I have to library ggplot2, then I have to write the command.
Okay, so we simply install the package, and then if we have to use it, then we library.
Yes.
Okay, ma'am. Thank you so much, ma'am.
Now till here clear?
Yeah, it is clear, but it would be better for us if you explain about that exponential value.
Exponential, sir, can it be good if I put it on the WhatsApp group? Because if I'm going to explain exponential value over here, it will take some time.
Sure, ma'am. Okay.
Because exponential, wherever the exponential value will come, it will be less than 0, or it will be less than 1. It will sum about 0 point something.
Okay.
Okay.
Okay, ma'am.
Okay. Now, any doubt till here how you are going to calculate the basic statistics over here?
Ma'am, what do you mean by nodes here? Nodes क्या ma'am ये? NAS and nodes?
Number of variables.
Number of variables are nodes, ma'am.
Knobs, I think so. In
number of observations.
Observations. Yes.
Okay. And NAS, ma'am?
NAS you don't have to work. NAS means that in my data, in share price, is there any null value? Blank तो नहीं है कोई भी column.
Okay.
तो जब आप यहाँ पे जो मैंने जो आपको ये share price की ये पूरी data दिया है, I have removed all the NAs and then I have given you the filtered data. But whenever you are extracting that data from the stock market, you will not get the filtered data. In that data, you will get NAs. Okay. And if NAs are there in your data, your R, or you can say SPSS or Stata, nothing software will work. First of all, you have to remove these NAs.
Ma'am, just a minute. Like NOB notes are saying ki number of observations, but number of observation can't be 1.318 something, मतलब less than 0 point something, क्योंकि exponential function में आ रही है ना इसकी value.
10 to the power 3. 10 to the power 3. Yes, you have to multiply by 10 to the power 3.
So, ma'am, plus 3 means you have to multiply and minus means divide.
Yes.
10 to the power minus 1, 10 to the power minus 2.
Yes. It's coming on the exponential part.
Okay, ma'am.
Now, if you are going to multiply it by 3, 10 to the power 3, you will get 1318 values, and you will see over here, it is given 1318 entries.
Okay, ma'am. Thank you.
Absolutely correct.
So, ma'am, can we just simply say it like this? Like if it is E plus 03, we just have to move the decimal to 3 places.
Yes. And if it is
minus,
negative,
then
we have to remove it to the left side. Yes, you have to move it to the left side.
Ma'am, SE means? SE mean?
Which, sir?
SE mean after some.
Standard error.
Standard error. Okay.
Now, can we move further?
Yes, ma'am.
Yes, ma'am.
So, till basic statistics is clear?
Yes,
now, let's move to the normality. How to check normality? Whether my data is normal or not. And in the time series, you will never get the normal data. Maybe you can say only 1% chance will be there. You are getting the normal data. Even after converting to stationarity, your data won't be normal, and we will work on it. So time series data does not restrict us to work on normal data. So we can do it on the unnormal data also. So for this, you have to write the command, and we are using the software over here. The test is Jarque-Bera test. So just write Jarque. You will get Jarque-Bera test and write the variable name, that is N225. Now see over here. Now, if I see the hypothesis of normality, the hypothesis is, what will be the hypothesis over here?
Mom, please excuse. It's Jarque-Bera test for basics, F basics or T series. T series we will pick.
And that
Yes,
is
it's for T.
Data is normally distributed.
Which, pardon, ma'am?
Data is normally distributed.
No. Data is not normally distributed. No, what is H0?
Null hypothesis.
Null
Yes.
hypothesis.
Now, null hypothesis, yes.
Data are normally distributed.
Yes, null hypothesis data is normally distributed.
Yeah.
So we can say data is normally distributed.
The same, okay, ma'am.
But over here,
ma'am, can you repeat Jarque-Bera test? What is this?
Jarque-Bera test.
No, what is this? What?
Jarque-Bera was a person who found the test for the normality. So the test was on his name, named as Jarque-Bera test. Now in this C, in N225, we have seen that p-value is less than 0.05, which means it is not accepting my null hypothesis. And if it is not accepting my null hypothesis, it means my data is not normally distributed. Got it?
Yes, ma'am.
So till here we
Yes,
can
ma'am.
prove it. Our data is not normally distributed.
Yes, ma'am.
Any doubt till here?
Ma'am, just one thing, like you said that in NAS, if any value is there, we have to remove those values.
Yes.
So for working on those values, first we'll remove it from the Excel sheet and then we'll again import it in R.
Either you can remove it from the Excel sheet or from the R also, you can directly remove it. For that, you can write the command.
Okay, ma'am.
na.omit.
na.omit.
Ma'am, but if we delete, won't the time series have, I mean, the lags of the time series
No,
change?
it won't. No, it won't affect.
So if data for particular time periods is missing, I mean, rows are missing, then it doesn't affect the
No,
analysis.
it won't affect, because we are
Okay,
just
ma'am.
removing it. Suppose in the Excel, your you can say your 5 cells are filled. On the 6th cell, somehow you left it, and from the 7th cell onwards, you are writing some part over there. So we have to remove 6 cells. So the way is either you remove it manually or you can remove it by the way of software. If you are removing manually, you just go to the Excel and delete the row. And if you are doing by the software, you can use the command na.omit.
na.omit. Okay, ma'am.
But again, if you have some variable, just give the name.
And won't the equally spaced time then get disrupted if that is the case? I
No,
mean,
it won't.
Because say 2012 I have a data, 2013 I have this NA, 2014 I am having a data.
Ma'am, it won't be possible. NA are always there in the stock market where the daily data is there. So
Yes,
why we are getting NA? Because the stock market works 5 days a week and 6 and 7 days is a holiday, and the stock market changes throughout the world. In somewhere the stock market closes, suppose in India, let's say my stock market closes at 3 o'clock, but maybe at some other place the time is not same. So maybe there must be, the stock market is not closed. Maybe on, let's say on Monday, India has a holiday, but maybe US don't have a holiday. So if I'm taking the data, some stock market will show the NA term. So you have to remove it.
And the space continuity will not be, I mean,
No, it won't be affected. No, in share price, we don't consider that. Because stock market works 5 days a week. On every Saturday, Sunday, you won't find any data.
Even one question I have.
Yes, sir.
Say data actually in time series must be a continuous data. Okay,
Yes,
what
yes.
actually you have mentioned to
Yeah,
me.
yeah.
Suppose it may happen that the stock market in particular day it is off because of
Yes.
certain
So
reason.
we will not consider it.
Then the one data is missing. Then there will be a break or not.
It hardly matters for us, sir, for stock market data, because the regularity in the stock market is Monday to Friday.
Now, for that, I have to remove that particular day the transactions will not be done. How it would be removed? Actually, you can tell me that particular day.
Sir, whenever you will extract the data, the stock market will tell you that on this date we have not done any transaction, so NA will be written over there.
Now, it will not affect my time series data.
No, sir. It won't affect.
Now, in your data, if you make a break, then what exactly the structure? It's the same figure you will get. If
Yes,
you
because whenever you are going to see this stock market data, you will see its work wherever it's closing. In the next day when the market opens, it's near about that only. So if the market is closed on Saturday and Sunday, and if you are opening the market on Monday, it will be showing the same part where it's closed on Friday. It will be near about that only.
Though we write it is for our purpose, we write day 1, day 2, day 3, day 4, day 5. Even if it is day 8, it is actually for the time series. It becomes day 6.
Day 6, yes.
I've got it. Then it becomes continuous, and there is no problem.
Continuous. Yes, there is not problem. Now see how you are going to remove it from your software. Now just give any name variable x is equals to na.omit, and just write, once you write na.omit, and just write your variable name n225. Now since there is no na in my term, so if I'm going to create it, it's created over here. Now you are seeing that it's 1318 terms only, whatever the terms are there in share price. 1318, because no NA is there.
Okay,
if, for example, 4 or 5 NAs are there, so it will remove it. If 5 NAs are there, so here you will see it will show 1:1313. Instead of 18, it will show 1313 because 5 NAs were there, so 1313 terms observations are there.
So one more.
Yes, sir.
One more.
One
more is added. Means one earlier it is 1317. Now it is 1318.
No. It's not 1317. In the previous, in D and R, we have taken differencing.
Okay.
So whenever you take differencing, first term is removed.
Okay.
So our x is 1318. If I put the if I'm going to see whether my data has NA terms or not, I put the part na.omit and then the variable name, and the variable is showing that 1:1318 terms are there. There is no NA. Suppose there are 5 NAs in the term, so this will be showing 1313. Instead of 18, it will show 1313. That means 5 NAs were there. That software has removed it.
Okay.
Himani ma'am, just a question, please. How long do you think the session will be? Because I have a prior commitment in case.
Ma'am, you can leave it, because main thing is that I can stop the session, but I have not started the ARIMA model yet. And we have, for the session, we have to complete ARIMA model also and ArchCart also till tomorrow, because from Thursday we have to start with the panel data.
And how long will you think that will take, ma'am, so that I can plan accordingly?
At least, ma'am, I should give the small introduction about ARIMA. If you all have the introduction about ARIMA, then I can skip it. If you want me to give the introduction about ARIMA also, then at least, ma'am, for half an hour you should wait, or at least for 20 minutes, so that I can just give the introduction about ARIMA.
Okay.
So you can work it at home. So you can.
We want it to be done in R.
So should I teach an ARIMA in R now?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
So okay.
Yes, ma'am.
So that will take another 20 minutes
ARIMA
approximately. Yes, ma'am.
You will teach ARIMA today only.
At least some basic I want to give today only.
Ma'am, how much it will take? By 2 o'clock we would.
Yes.
Okay, fine. Thank
I'll
you.
try to wind up before 2 o'clock only.
Okay, fine, ma'am. Fine.
So that means now the differencing is clear. Now let's move to ARIMA part. What is ARIMA? What is ARIMA?
Auto-regressive integrated moving average.
What is integrated?
Auto-regressive integrated
moving
average.
Now see over here, auto-regressive shows that your data is linked, is correlated with the previous lag or not. Maybe AR1, AR2, lag 1, lag 2, lag 3, lag 4, lag 5. So that will be shown in auto-regressive part. Moving average will show whether the residuals, your error term, is related to its previous lag or not. Got it? Because whenever we are working on any data, either the data is related to its own lag or some exogenous variable. Now let's take the example. Yesterday also I gave you the example. Suppose a child is born in a family. Now if you see the behavior of the child, now whenever we talk about the family, family means the father side family. So if I'm saying that the behavior of a child is exactly same as his father, that means one generation back. So lag 1. If I'm saying its behavior is just like his grandfather, so that means preceding that generation, that means lag 2. But now if I'm saying, so that is auto-regressive. So I have to find, sir, can you mute yourself? So if I'm saying auto-regressive, that means how I am correlated, related by my previous lag. Now, if we move to moving average means error term. Now, when the mother came, mother is an exogenous variable because mother does not belong to the same family. We marry a lady, that lady belongs to some other family. So it can happen that the behavior of a child goes on his mother, which is mother is an exogenous variable over here, or maybe is parental, or you can say nani pe gaya hai ya nanu pe gaya hai, mama pe gaya hai. So that means a exogenous variable unki lag pe gaya hai. So whenever we are talking about the same lag, we will move it to auto-regressive, and we are talking about error term. That means lags of error terms, we are talking about moving average. Got it, this part? And now integrated. The word integrated means your stationary. At what level your data is stationary? Whether your data is stationary at level. If my data is stationary at level, I'll name it at 0. If my data is stationary at first difference, I'll name it at 1. If my data is stationary at second difference, I will name it as 2. Got it? Till here it's clear? So that means I can write that my variable yt is a plus byt minus 1 plus et. So what can I, this model is what? What is this model?
Auto-regressive. Auto-regressive.
So this is AR1. This is my AR1 model because my y is a variable. Y is dependent on its previous lag. Yt, that means current situation is depending on its previous lag, lag 1. Previous year pe depend hai. So that is regressive on its own. But I have not taken et minus 1. So that means in this term, MA is not there. Now, if I am taking yt is equals to a plus b1 yt minus 1 plus b2 yt minus 2 plus et. Then this will be
AR2.
AR2 because it's depending on the two previous lags. Now, yes.
Excuse me, ma'am.
Yes.
Can you repeat it from YT, AR1 and
Now see, ma'am, this is an equation that I have written that yt is dependent on only its own previous lag. No error term I have taken. I have not taken the lags of error term. So that means this equation is only AR1. So my model says that the values are dependent on its previous lag only, but it is not dependent on any exogenous variable.
Okay, ma'am. Fine.
So it is AR1, auto-regressive at lag 1. Now in the second equation, it's yt is equals to a plus b1 yt minus 1. It should be yt minus 1. So that means, and I have also written b2 yt minus 2. That means the current value is dependent on its previous lag and also on the lag which is immediately preceding the previous lag. So it is AR2.
Okay.
Again, ET is not there. Now suppose I write, instead of this, I write B3 ET minus 1. Now I'm showing that the value is dependent on its own also and on its the error term also. So it's become AR2 MA1. So we can write the model is ARMA model. This is ARMA model, which is 2-1. First abbreviation, or you can say first will show you AR term and second will show you your MA term. Right now we have not gone with ARIMA. Yes, sir?
Ma'am, in this AR21 model, in MA case particularly,
yes,
my question is that when we are predicting any variable with help of its error term, which is unknown, which is
yes,
unrealized value,
yes, it's unobserved.
Unobserved. So will it be rational to, it will be rational to find the values with help of unknown, unobservable value?
Yes. Software will take care of everything and we will prove it over here.
Ma'am, so the difference between the AR1 and the second one is that in first case, the error term was not I mean, the YT was
yes, YT is not dependent on error term.
Because over there is no the T is the
yes,
same year T.
T is yes, T is same.
And
so
over here it is depend on the previous years.
Yes.
And then also why don't we have a plus ET again, ma'am?
It's because it's dependent on the error term, but on its previous lag, not for the same year.
Okay, so we do not have to. There is no error term in this year,
particular
year.
No, error term is there. It is there, but for the previous year.
Okay.
So that's why it's written MA1.
और मैम फर्स्ट वन में एरर टर्म है ही नहीं जहाँ पे आपने लिखा है।
फर्स्ट में नहीं, आप अगर एरर टर्म हटा भी दोगे तो नहीं होगा, आप ऐसा लिख सकते हो।
ओके, मतलब फर्स्ट में कोई एरर टर्म नहीं है, लेकिन सेकंड में हमने एरर टर्म लिया।
बट एक्चुअल यस, एरर टर्म है, बट माय डेटा इज नॉट डिपेंडेंट ऑन दैट एरर टर्म।
ओके फाइन। और मैम जो सेकंड में जो आप एक्सोजेनस वेरिएबल की बात कर रहे थे, तो वो फर्स्ट में नहीं है, लेकिन सेकंड में वो भी है। एरर टर्म उसी को रिप्रेजेंट
हाँ, एक्सोजीनियस वेरिएबल एरर टर्म है। एरर टर्म हर एक में होता है, बट वी आर शोइंग दैट वेदर माय डेटा, इफ आई एम प्रेडिक्टिंग द फ्यूचर, if I'm predicting the future price, my future price will be dependent on that error term or not.
So how do we understand from a data set that whether it is dependent on the previous one or it is there? How do we determine?
Yes, there are two methods. First method is we will be creating various models over here, and we will validate those models, and we will see with the logly likelihood value or AIC and BIC which model is best.
Ma'am, so it is a trial and error method basically.
No. It's a trial and error also, but it's not only the trial and error method. If we work in R has a command auto.arima. If we will click auto.arima, it will automatically give you the error term, whether it's dependent on the error term or whether it's dependent on its own lag. It will automatically give it to you.
Okay. So that's why we have taken these two models. So we came to know that our data is dependent on error term or not.
Yes. So there are two ways. One is hit and trial. You create 4-5 models and you will choose that which model is the best one.
The second method is this.
Second method is you can directly use the command auto.arima. So once you use the command auto.arima, so that
अगर ये नहीं होगा तो इसको इंस्टॉल करना पड़ेगा या ये ऑलरेडी पैकेज में होता है?
नहीं मैम, ऑलरेडी नहीं होता. We have to install it. So see, if I am writing auto.arima, it's not coming over here. Now see over here. I have not installed it. So I am writing auto.arima. It's not coming. So first of all, you have to install the package forecast. So I have already installed. So I'll just go to the library and just write forecast. Because this auto.arima model we are creating just to forecasting the values. So now if I am writing auto.arima, Now let me check whether I have done it auto.arima or forecast. Have you all installed this library auto.forecast model? Have you all done this?
Ma'am, one question I had.
Yes, sir.
I can take average of that. You have taken past 2 years. I can take average of that. That model can be designed like that. It is statutory.
No, you can't take the average, sir. Now it's showing that it is correlated to that term. It's not taking average. It's just mentioning that it is correlated.
If I want to study the last previous year's average basis, it can't be done.
No, sir. Because we are not saying it's dependent on that. Because the rule says that if we work on the stationary data, it says that it's have a finite memory. That means it can remember only till few years or few time period. It does not have an infinite memory.
Okay.
So, ma'am, basically MA or AR or ARIMA, we are trying to get a stationary data out of it.
It will work only on stationary data, only on stationary. If the data is not stationary, it won't work.
So before sending data, we should make the data stationary before sending it to ARIMA command. Okay.
Now, once you make the data stationary, you will see that we have done the differencing of this part. So I'll just now validate it whether my data is stationary or not. And for validation, we have to use the ADF test, augmented Dickey-Fuller test. So just write the command adf.test. And first of all, see, let's see N225, whether my data is stationary or not. Now see. Now see the p-value over here is more than 0.05. And if I go to see the whether my data is stationary or not, the hypothesis says H0 will be my data is stationary. My data is non-stationary. And p-value, since the p-value is more than 0.05, so it's validate that my null hypothesis is accepted and my data is not stationary.
Excuse me, ma'am.
Yes.
Ma'am, in this ARIMA model, actually we are estimating any variable with help of its past values.
Yes.
But we are saying that the data should be stationary.
Yes, data should be stationary.
And for making data stationary, we are differentiating.
We are log differentiating.
And for purpose of differentiating is to remove the effect of past values.
Yes.
So what does it mean? It is something contradictory kind of thing.
No,
In one side,
sir.
we are...
See, whenever you are not removing the stationary, their mean, whenever you will calculate the mean won't be constant at two different time periods. So whenever we have to predict the future, we have to make the data stationary, and stationary says that whenever you are calculating the mean at two different time periods, your mean will be constant. Now, if your data is not...
Ma'am, when we have removed the effect of past values by differentiating...
We have not removed the effect. We have just seen whether the memory is finite or not. Because
I was thinking that if you have actually detrended and done the first difference, why have we done the ADF test on N225? You should have done it on
Yes. It's for just to show you that the previous data was non-stationary, or it was non-stationary. Now, if I'm going to check it on adf.test on this data RN225. So RN225, if I'm going to test it on this, now you will see that my data is now become the stationary. Now I have to work on this file only.
Yes, ma'am.
I will work on RN225. I will not work on N225 now. But in the research paper, whenever you are showing, you first have to show that your data was not stationary. You have converted, you have taken the log differencing, and then you have to make the data stationary. So you have to show both the parts before converting to the stationary also, and after converting to stationary.
Okay.
And you have to validate it by the ADF test.
Okay.
So till here, any doubt?
मैम ये इसके आउटपुट में lag order 10, how do we interpret that?
So it's dependent on its 10th value.
Ma'am, that comes automatically, or we did something?
No, it comes automatically. Software takes care of everything.
Okay, ma'am, that means the 10th year or whatever was there, the time period, that has a effect on the today's.
Till 10th, there is an effect.
Till 10th, there is an effect.
Till 10th, there can be the effect over here. But now we are going
I
to
mean, past 10 days. I mean, past 10 days can have an effect now.
Yes, if you are taking daily data, so it will be past 10 days. If you are taking, suppose my data is monthly, so past 10 months.
10 months.
So past 10 periods, the lag order is there. Now till here, any doubt?
Madam, ARMA model is an arithmetic model.
ARIMA model is arithmetic
Arithmetic model.
No, sir.
It is based on theories.
It's based on theory, sir.
But in case of MA, there is no such theory which explains the the behavior of any characteristic with help of its error term.
Sir, yes, error term. The difference in error term is that we are taking the difference of observed and unobserved from the pure population. Now see, if I have taken this data, whenever I am doing the time series, I am taking the actual population. I am not taking the sampled part. There is a difference between population and sample. Sample means we are choosing a small area and then I am creating a model. But in time series, what we are doing, we are creating the model on complete population. I cannot take a small sample and create a model. So whenever we are taking from the whole sample, we say that it's unobserved.
Ma'am, the lag order, is there a minimum value for it to be validated? That
No,
it should not be less than.
No. It can be 0 also. I can say that my behavior is unique. My behavior does not depend on my previous lag.
Okay.
It can happen. You will see. Okay. If you go for Argentina, just try it on your own. If you go extract the data for Argentina, go to the index of Argentina and you will see whenever you are going to predict the values, it will come 0, 0, 0. That means neither is dependent on its own lag, neither is dependent on its error term lag.
Okay.
So it will be 0, 0, 0 only.
Explain again. Log order 10. Can you explain again?
Which, ma'am?
Lag order 10.
Lag order 10 means it can be dependent on its previous 10 terms.
Previous 10 terms.
Yes, 10 periods, 10 terms. But right now I'm not saying it will depend, because we will be creating the model and we will validate from that whether my lag order is exact 10 or not, because this software takes automatically on its own. It's not proving it right now. Now, while creating the ARIMA model, we will see what will be the lag. Now, till here, any doubt?
Kind of decay Fuller test has some meaning. I mean, minus and plus sign.
No. Okay. You don't have to go for this. It does not have any meaning over here. Now, we just have to see the p-value just to validate whether my data is stationary or not. Now, I think till stationary, no doubt is there. So, can we learn?
P-value 5% significance or 5% significance or 10% significance?
Sir, 5% से कम है ना ये value.
5% से यदि 10% आए तो उसको रिजेक्ट कर दे. 5% लेके चलेंगे.
5% लेके चलते हैं सर.
Okay.
So till here, no doubt is there. So can we start with the modeling of ARIMA tomorrow?
Yes, ma'am.
So should we wind up now?
Yes, ma'am. We should do it tomorrow.
Because I know that it will be more enough.
Yeah.
Thank you, ma'am. The lecture was very great. It was.
Yes, ma'am. Thank you, ma'am.
Thank you so much, ma'am.
And informative and very well placed. Thank you.
Yes, ma'am. Thank you. Statistical analysis. लेकिन क्या करें?
Himanika, thank you.
Thank you,
technical
sir.
question.
You should just know which
Ma'am,
are the
video
apps
भेज देना please.
का data
Yes,
डालना
yes,
है,
yes, sir.
automatically download होता है. है. Give an example where you have to do. मतलब इसका query उसका query पूरा 1-3 घंटा चलता है. You said that half an hour's work.
मैम एक टेक्निकल क्वेश्चन था.
Tomorrow, where differencing is to be done twice.
Yes, there will be the cases, ma'am, where the differencing is to be done twice also.
Thank you.
Okay.
मैम जो हमारा नॉर्मेलिटी टेस्ट है उसके लिए हम लोग जैक्सबेरा टेस्ट को क्यों प्रेफर कर रहे हैं? वो तो स्क्यूनेस और कोर्टोसिस के बेसिस पे नॉर्मेलिटी टेस्ट करेगा.
सर नॉर्मेलिटी के बेस आप स्क्यूनेस एंड कोर्टोसिस से भी नॉर्मेलिटी देख सकते हो.
वो जैक्सबेरा तो वही करेगा, लेकिन हम लोग शिपारो विल टेस्ट
शपीरो भी कर सकते हैं, लेकिन नॉर्मली जब आप लिटरेचर से देखोगे, लिटरेचर एलियस टेस्ट देखता है. इवन आप फिलिप पेरेंट टेस्ट, जार्के-बेरा टेस्ट, आप कोई भी टेस्ट यूज कर सकते हो, शपीरो भी कर सकते हो सर.
Yes,
अच्छा मैडम, आपने लिटरेचर का क्या बताया था? I missed out. Somebody was speaking during the.
Sir, whenever you will see the literature, that means whenever you study the previous research papers, they will use the Jaarke-Bera test, and very less literature on the time series where you will see that the Shapiro is being used. So if we will go with the validation of the literature, the Jaarke-Bera test will be used.
लिंक भर के हमारे पास ये नहीं किया ना, रजिस्टर नहीं किया ना.
Okay. Can the participants can mute
लेना
themselves?
पड़ेगा मुझे.
So let's stop over here, and we will continue with the same model, with the ARIMA model tomorrow. I request all the participants.
मैं अटेंड किया था, मेरे को तो आर्ट बेटर लग गया. इट इज बेटर. मेरे को पूरा समझ में आ रहा है. व्यू से मेरे को सिर के ऊपर से सब चला गया मेरा.
सर कोई बात नहीं, आप आर से कर लीजिएगा.
हाँ ठीक है. एक्चुअली जस्ट आई एम टेकिंग आइडिया ऑन दैट एक्चुअली. ठीक है, अच्छा चीज है. एनीवे वेरी गुड. थैंक यू मैम.
Okay, thank you sir.
Everybody, please note that the attendance cum feedback form is in the chat box. Kindly fill that form.
May we leave now? After filling form?
Yes, sir, you can leave, and we will take this opportunity to thank Dr. Himani Gupta and Dr. Anu Bhardwaj for their time and efforts, and to all the participants as well for taking such keen interest in the program. Kindly fill the attendance cum feedback link, which is already shared in the chat, and then you can leave.
Okay, ma'am. Thank you so much. Thanks a lot.
Welcome, ma'am.
It was a very helpful session. Thank you, ma'am.
Everybody, kindly fill the Google form. We will close the meeting within another 2-3 minutes. Please fill the Google form.
हो रहा है.
Okay.
मैम सबमिट हो गया.
Okay, sir. We'll close the meeting in another 1 minute. Everybody, please fill the feedback form. If the link is already open in your system or your phone, you can leave the meeting because the link will remain open. The meeting does not have any linkages with the form.